bend it when we place it down? Like when you, so also like when we did this test in the pool, like I was leaning it a lot, and then it also starts to break, like just doing the, and I think this probably happened when we put it down. So I think this is not new, but we just didn't see it yet.
No, it's not new. I think it's, yeah, you see it over. But there's mold here, but the inner part,
but the inner part is still fine.
Yeah. Yeah. Okay. Yeah. Okay.
All right, welcome for anyone joining us, and I'm sure we'll continue to have folks trickling on in, but you are joining us on another dive down to the East Pacific Rise. We are at a depth of just over 2.5 kilometers below the surface of the ocean. What we're looking at right now is experiment 1, which is this mesh box that has been sealed as best we can down to the seafloor, including filling some of the cracks with like a silicone caulking material, which in the chat someone asked, what's the blobby stuff? That's the blobby stuff. And we're going to be applying more of that today, because for today's dive we are going to be placing experiment number 2, another mesh box that we're going to seal down on the seafloor nearby to experiment 1, but at a slightly different area. So it's quite the process. Our pilots did a great job with the experiment 1 though, so it'll be fun to watch as they sort of prepare the site and then get the box in place. A second box will go over top of that to then fill the area with a staining dye. It's all going to look very odd, very strange, but these boxes will then be left in place for up to 10 or 11 days before scientists come back and I guess why can't I think of it? Reacquire them, pick them back up off the seafloor, and we'll see if anything has shown up inside, coming up from the hydrothermal venting fluid in the area. So if you are joining us for the first time, we do watch the chat here on YouTube as well as Facebook. So if you have any questions about what you're seeing, about the science, about the area, about the remotely operated vehicle Sebastian, which is the vehicle you're getting footage from, or from the research vessel Falcor 2, which is the ship on the surface where we're piloting this from, you can type those questions in the chat and we will try to answer them as we can. So today's going to be kind of another intense day of getting these experiments in place. I'm going to toss it on over to the scientists, but they're also going to be very busy making sure that all of this is done as it needs to be. And the pilots are going to be intently focused on getting it done. So it might be a little bit intense, a little quiet in here, but I'll do my best to get questions answered as we can. So welcome, and thank you for exploring along with us.
Because also here you see it's okay.
That's a good point as well, as we do have Salvador actually in the chat here as well. So he is in mission control with us. So you'll see him answering questions and conversing in chat as well over on YouTube. If you're on Facebook, though, I don't know.
I think it's like probably like half a centimeter, so it would still be fine for the silicone, but kind of probably do have to remove that here, because otherwise we cannot.
So the frame that you see here in place was left yesterday. This frame is roughly the footprint of the experiment itself. So we use this frame to determine a good site for experiment, in this case experiment number 2 of 3. And so right now the scientists are kind of reviewing with the pilots and with each other where this was placed. The obstacles at the site, there are some cracks that extend beyond the edge of that frame, and so in order to get a good seal with the experiment, they're going to need to fill those cracks with the caulking. We have the tube worms here as well. This is a hydrothermally active location, So there is hot, mineral-rich water streaming up from below the surface of the ground here. You can see that shimmering water there. That's that hydrothermal venting fluid that's coming up. So lots of animals that are associated with these vents. We have the tube worms, the Riftia tube worms, kind of look like a lipstick. And we also have some mussels here as well, venting mussels, and then even different tube worms, little tube worms like right there in the middle of your screen. We'll also see probably some squat lobsters, which are a pretty common crustacean around here. They look like little tiny round crab. There's also been some white, I'm not sure what species they are, but some white vent crab around as well. Look much more like your traditional crab. And as far as fish go, we have mostly seen eel pout, but I think we got a nice little snailfish at the end of the dive yesterday briefly before we left bottom.
And now in silo, report.
I'm ready to take the frame right there.
Where?
Report.
Report.
Report
You
for
want to
the
take the frame?
click on the
Yeah.
report
I have
for
it
the
also.
click it.
I remember very good.
You just
the
took a
picture.
photo.
Yeah, also yes.
All right, so we have a question of what's in the mesh box. Currently, probably not a lot, but here's the idea of the mesh box. The mesh allows the seawater to flow through, so the pressure's not building up since we're putting this on top of some venting fluid. But we are curious what that venting fluid might be bringing with it, particularly in terms of fauna. So, you have these venting ecosystems. They frequently will have the same organisms at them. So how do those organisms get to a new vent? When a vent first pops up, how do they get there? Well, these vents have water coming out of them, but that water also has to go in, down into the ground at certain areas as well, sort of an intake to the system. And so we're curious if the intakes are actually sucking in larvae or perhaps gametes of some of these organisms. And then obviously wherever that water is spraying back out at a vent, if those organisms are coming right out there, if they're coming through that water itself, then they're already in a prime location to settle down and sort of establish a new vent community. So the mesh box was placed down over an area where that water is coming up, and then a stain will be applied, and that stain sort of colors everything that's in that area when the box is first placed down. So we have an idea of what was already there. We're going to leave that box there for a while, and then when we come back and we pick the box up, we're going to see if there's anything new in there that didn't get stained, that wasn't there when the box was first placed. And that might be something that came up through the vent fluid then in that case.
Yeah.
There's no chance it's not.
So as part of the site preparation here, we're going to need to clear out some of these worms so that we can more cleanly apply the caulking down into the crack here to seal the experiment to the rock.
Probably wait a moment because probably it's if you just grab the not the worm but just the white the tube.
for its, you know, to,
These are hard to grab.
yeah.
So small.
So you will not collect these in the biobox. No?
I think the other grab is better for this, not the soft one. The soft one is not working
yeah.
well with 2 points.
Maybe the other one is working better with the not with the red stuff, like with the hearts.
Would you try it? You want to try the other armor? Just the general.
Crap is coming. Ah, there's food.
Yeah, I think like right after we put the box down, we checked out the box yesterday, and there were already crab just climbing all over the box. They are quick to investigate. So if you didn't catch the other experiment when we placed it down, you might have heard me talking about, and then we're going to stain everything. You know, like, okay, how are we going to do that? Well, we actually have a bag of dye on board the vehicle here. You can see it there on your screen. This is sort of towards the back of ROV Sebastian, and then there's a little pump that'll just pump that out. And so when we put the mesh box down, we actually have another box that goes on top of that isn't quite so permeable. You know, it's not mesh. And we can pump the dye into that box and fill anything inside of it with the dye. But then, you know, we only want to dye what's there when we deploy the box. So we need to then suck all the dye back up after it's stained everything and collect that box back up. So it's a complex little procedure here for sure.
Right, I'll dry that off to the left.
Actually, I just noticed that in one of our other cameras here, you can see the first experiment over to the side there. So that's what that box is off in the distance. The not so distant distance.
We really hope to make this.
In this view, you can also see the main camera, our science camera, which is the one that you're usually watching. I'll kind of toss that up like so. So you can see the view from that science camera, but then the main view that I've got up right now, you can kind of see how that's able to articulate and follow the motion of our manipulator arm. The manipulator is being piloted by one of our pilots. And then the camera controls can either be by a pilot or by sort of the science watch at the time.
You're good with it?
I think it's good enough. Yeah?
Heavy? Okay.
So again, just clearing back the tube worms a bit here so that we can apply the silicone caulking.
Here again, and then yeah.
Very good. So the next thing we'll do is to take the suction sample. So from this you can simply also suck up. Yeah, it doesn't matter, but it's like probably easier. So you want to clean now with the suction sampler the area that it's in.
Rest of the highlight.
Just the square area of it, right? Not,
Yeah.
not this one, yeah. Keep going left. Okay.
And with the fine mesh, so either 1, 2 or 3.
Okay, we are in 2 right now.
That's good. So this will be sample number 32 solder, suction sampler with fine mesh.
And once this second experiment is deployed today on the dive, time permitting, we'll be cruising around collecting some samples as well. Anyone who was around for the latter portion of yesterday's dive probably saw us collecting some tube worms. We collected a several meter long tube worm, and the pilots had to kind of tuck that into one of the bio boxes on the front porch of the ROV. The front porch today, of course, is more taken up by the experiment. So on the right side there, we actually have the mesh box. And then on the left side, we have the dye box that will go on top. And so you can see kind of at the edge of that mesh box, it's turned in a way that the bottom is on the left side of it right now. There are dive weights around the inside to hold it down, but then there's also that silicone seal around the bottom of it. So we can press that down onto the bottom.
That's what I was saying. Yeah, I think it's under. I think you're okay. Under. I'll keep an eye on it. But yeah, you're fine. Okay, we'll bring in some.
So currently we're using our suction sampler. Think of it as an undersea vacuum. And we are just using that to kind of clean the area a bit. That suction sampler actually pulls down into some containers on the side of ROV Sebastian. So you can see there, you know, little bits of debris and detritus kind of flowing in there. But that allows us to make sure that things are actually making it to the collection containers. tube worm collections. I got a question on how those have been going. Obviously, we collected like the really large one yesterday, but we've also gotten some little clumps here and there. So there have been some dissections going on for sure. There's also some pressure experiments with little pressure housings that they're able to use to get these things back down to the pressure that they're facing here in the deep sea. And I don't know exactly how far we've gotten with those, but I do know there's been some progress with those. So maybe we can get an explanation of those a bit later on. And there will be some instrumentation that will go kind of in the middle before we put the box on top. Anyone who's tuned in for some of the earlier dives on this expedition, you may have seen the colorful sponges. We do have some of those that will go, as well as a temperature logger that will sort of log the temperature of the inside the box there.
If you can hold it with this direction. Like to get like basically the base of the muscles and tubums.
Base of the muscles.
Tubums hold it like with like
Yeah, yesterday we had a collection of a tube worm from a clump. We didn't take a whole clump like we had on some earlier dives, but we collected a tube worm that was like, I don't know, 2 or 3 meters in length. I didn't see it when it made it up to the surface, but it was quite a long tube worm that the pilots then actually used both manipulators at the same time, working together to sort of coil that up into one of the bio boxes. That was towards the end of yesterday's dive. Of course, we know many folks tune in for these dives, and you know, some of them are quite long, or depending on where you are in the world, it's a little inopportune, the timing. So if you're trying to follow along with the expedition, with the dives, even if you can't watch live, you can follow along with the hashtag #VentUnderworld over at Twitter. We get posts that are getting put up with that by the scientists themselves, but also by people watching, you know, posting frame grabs and that sort of thing. So you can follow along over there. But you can also check out the cruise or expedition page for this particular expedition at schmidtocean.org. I'll post that link in the chat here in a moment. But over there we have information about the expedition, about its goals, about the area, about the scientists on board. But we also have a series of blog posts that will be posted throughout the expedition by the scientists themselves. So I'll get that link in the chat. I have some folks commenting about the hours that they're able to watch. it's always interesting to hear where folks are tuning in from. And of course, Schmidt Ocean has published the decadal plan of where we hope to be exploring over the next 10 years or so. That's on schmidtocean.org as well. But we will be kind of scooting around over the next 10 years. So obviously the primary objective for the dive today is the placement of experiment number 2. On yesterday's dive, we kind of cruised around and located a good area for experiment number 2, which is where we are right now. And so there is one more of these boxes after this one to be placed as well. So we're still going to have to identify a third area at some point. This is the 547th dive of ROV Sebastian. And I would anticipate tomorrow's dive. Currently the plan is to be kind of scooting around at a vent area, looking for a potential area for experiment number 3. So tomorrow's scooting around a little bit more. Today is installation deployment of this experiment.
Try to keep that. There you go. Under it. Yeah. Might have to look at it over it. So if you tip it so it's that back end is lower, I think you should be able to get it back under. You might be right if it doesn't go under it. I want you to be right. It's better. Yeah, now you're a little low. It's fine like that. I'll get it right. It's under it. Just set it down in front of it. Yeah. It's scratched. It's weird. Get a little bit of zoom. Just remember it is in the sheet.
Oh, it isn't. We don't need it anymore. So it's like, if you want to use it at this moment, but then you cannot move it.
Yeah.
Currently looking at moving the temperature probe there.
I think we need to pull the temp probe out and stow this, because like you're saying, every time we move, we're going to have an issue. And then the first time we need the temp probe, we're going to be tangled up.
You know what I mean? Like, you can get enough grab it on.
Yeah.
That's not what I wanted.
Like for the experimental site now, we do not need the suction sample anymore, and we do not need the temperature probe.
I have some in mind, but it's easier to just do it than
Yes.
explain it. If that's all right. You got it? Okay, good job.
I really was about ready to give it to you. So.
No, no, no.
Oh, all right. Here we go. Give it a shot. Left it up with the tip of it. So,
With the rear of it, I'm gonna try to slide it.
oh, with the wedges under it, anyways.
Yeah.
Should be good.
So now if I can just pick that up with the rear of it.
Yeah, it should be good.
Okay.
Should be okay. Just move it in box like that. Push down.
Okay, very good. So now we seal the cracks with the syringes. Or should we first place the experiment? What did we do last time? Like we also have these sponges. We placed them, I think, after we had the.
Okay.
Oh, what did we do? It doesn't really matter. But it's easier to first deploy the sponges before we start cleaning.
Sponges.
I'll just turn on.
Oh, what did we do? Do you remember what we had first?
First the gluing and then the sponges.
Just the glue, then the sponges?
Yeah, because
In case we mess up with the glue, then we can still, yeah, okay.
both
There will
ways.
be no mess.
So sorry, first the syringes. So, yeah, the syringe first, sorry.
Okay.
Oh, a question about some of the upcoming cruises. So over on schmidtocean.org, we have the decadal plan published, which is just kind of where we're going year to year, but not necessarily the cruises that are in each area. But we do have some information on upcoming cruises for the rest of 2023. There's some fun ones over there. Honestly, I'm hyped about any cruise. It's always fun to learn about the projects. This experiment, for example, just blows my mind. So I'm quite excited to see what we end up getting from this.
Yesterday, that makes more sense
I wouldn't, because then it's gonna be rigid and it might like twist. I
Oh,
think
that's
just grab the rope and we'll do the handoff. I know it takes like 2 more handouts, but
No,
that
that's
is what we have.
Questions in the chat about the Midwater. So the period where we're ascending and descending through the water column itself, if we've happened to spot anything. So sometimes we try to stream those if time allows. Too early to say for today what we have. But on the way down, we usually spot some planktonic critters, for example. Siphonophores, we'll usually see a couple of those, or ctenophores, right, comb jellies. Usually see a few of those as well. Near the surface, on both the last expedition, the Octopus Odyssey, and this current Vent Underworld expedition, there have been mahi-mahi at the surface. I mean, we don't really see them in the ROV, but during recovery, we have seen those up at the surface. So here you can see one of the syringes that will be used to plug up some of the cracks here where they are going to cross the footprint of the experiment. So this is one of the portions, actually I would say pretty much from now until the end of the experiment deployment, the two pilots are really going to be working together with both manipulators.
Hold it down, she need me. Rotate to get out of edge. I think. I can hold it in position. So yeah, I can so you.
So we'll start again on the right side.
Okay.
So Sabine, what's in the syringe? What is this?
It's a glue that you use if you have a swimming pool to seal the holes off.
Yeah, so it's pretty much just an off-the-shelf product that you've been able to adapt.
I really just Googled and looked for material that we probably could use here.
Yeah. So if you didn't quite catch that, like this, what we have in the syringe is essentially what you would use to seal a crack at the bottom of a swimming pool, or if you had like an outdoor pond with a liner at the bottom that you needed to kind of fix. Yeah, so sometimes off-the-shelf is usable, and then other times you have to get kind of creative and custom build something, like the mesh box itself, really, I suppose. No one makes a mesh box for placing on hydrothermal vents.
No.
We got some folks trickling in. We are currently 2.5 kilometers below the surface of the ocean at an area near Tika Vent, a hydrothermal vent on the East Pacific Rise. So that doesn't necessarily tell you too much because the ocean is huge. So to give you an idea where we are in relation to shore, we are about 2,000 kilometers to the west of Costa Rica and about 1,000 kilometers south of Mexico.
The push, and I want to see which angle that comes down.
It's not straight going.
Yeah, I have it at a little bit of an angle, but are you unhappy with where that's coming out?
No, that's fine. So we want to fit like so. We are here.
Okay, I'll
That's
shift
good.
a little to the right. You want to stop?
I'm a bit afraid that the syringe will break because we have quite a lot of, well, it will not break probably, but not, it's not really so smooth.
Yeah, I'm not sure what brand name of silicone caulking they're using. We get it in these nice little syringes from the scientists.
idea of where that's gonna land? Okay.
I think it's, yeah, basically in the crack. Yes, the crack.
Yeah,
But it will come there.
I think so,
Yeah.
yeah.
You wanna try and move it out, right?
Give you a little closer look there. We've been in that overhead view for a while, just getting the big picture. But you can see there the application. So it's a little troublesome because, of course, we have to squeeze it out of the syringe, and it doesn't, it's not so tacky that it just immediately sticks to the rock. So they kind of gotta wiggle it and try to get it off from the syringe without just pulling the whole blob away. And then once the box is placed on top and pressed down, it'll be a better seal.
Okay, let's get it a little bit over there, and I can adjust it more.
Mostly this is just making me think of applying thermal paste while building a computer, which could be a bad memory for some folks, I think. I don't know.
Good stuff. Appreciate it.
Okay? Now, this other crack.
Just a little bit is like needed like right here. Because the rest anyway the tube was like square.
Sure.
The curious crab that we had kind of checking us out. They seem to have left for now, but still lots of life on the screen. These hydrothermal vents, right, are just always been fascinating to a lot of folks due to the life that appears at them. We have these large Riftia tube worms, the ones with the red gill structures that come out there. Kind of I feel like really just the archetypical vent organism, right? 1977, dives down to the Galapagos vents in Alvin, and then all of a sudden they just see these towers, these castles of worms just hanging out. And I think that is a good term for it. I've seen it kind of brandied about is the castles as we go by, and some of them do look very almost cathedral-like. And so finding these communities so deep below the surface, it's certainly fascinated people for ever since, really. But we have smaller worms here as well, besides those large Riftia. All those little white doodles all over the rock here. Those are all tube worms of their own. The kind of golden brown items look a little bit like clams. Those are mussels, so another bivalve. We haven't really been visited too much by more mobile critters. We had a couple crabs stop by, and there's actually one up at the top of the screen there, making his way across the very, very top bar. But no fish have really swum over yet to say hello. Looks like there's a tiny little kind of pinkish purple worm cruising along the ground at the bottom of the screen, just to the right of the little tube worm clump at the very bottom. And that's one of the things we'll do probably while the box is being filled with dye, and while we're waiting for that dye to actually stain everything that's in there. That's usually a good opportunity for us to kind of look around with this camera and really get a good zoom and see what these smaller critters are. We've seen lots of little limpets and lots of little snails as well.
The box like should go like here, so this shouldn't matter. I'm just not so sure if we should put a little, I don't know. If we place the box like it's good, we don't need it here. But you can see here's a bit of
Remember that it was a little higher?
higher. Yeah, so I think it's fine.
Sure. But remember the frame was a little high?
Higher, yeah.
If
So
we
we
put
put
it-
a bit hidden here.
Just for safety? Okay.
So basically a little bit there.
This is the top part, and then a little bit
Yeah, down like here. Not a lot, just a little. Doesn't.
So I believe we brought down 2 syringes today. The last deployment we really only needed 1. Since we're looking pretty good right now on where we definitely know we needed to block up some cracks. The pilots are currently discussing, and looks like we're going to go ahead with just placing a little extra along where we think the boundary of the box will be. Just a little safeguard.
I think that's enough.
Okay.
We can
You want to try to
go
drag
like
it down
and
or
that. I think what because the difference is we have like one long line.
The former instrumentation. Yes, that's what the first
It's not enough weight to
Yeah,
pull it off.
yeah.
Yeah, so there you can see the caulking doesn't really adhere to the bottom right away. So. There we go.
Great. So I think we can pack away those rich.
One of the differences, you can see experiment 1 in the background there. One of the differences between experiment 1 and experiment 2 so far that
Almost 10,000.
we've made really is that experiment 1 we really cleared everything out from under that footprint. But on this one, wanting to leave the substrate a little more intact, I got an eel cruising by in the background there.
I think I need that.
In order to leave the substrate a little more intact, we are leaving the tube worms that are currently in the experimental site intact.
Is there a reason why I wouldn't just grab the rope?
Well, I don't know if you were gonna be able to reach all the way over and put it in.
No, no.
Oh,
But,
no.
did I? Did I get that over?
Yeah, that was this one.
Oh, okay, I'm sorry. Got it. Okay. Good. Very good.
Been streaming just shy of an hour here, so for anyone who might have just joined us, not quite sure what you're looking at, you're watching live footage from the remotely operated vehicle Sebastian, coming from about 2.5 kilometers below the surface of the ocean at the East Pacific Rise. And currently, this remotely operated vehicle, or ROV, is being used to place an experiment at these hydrothermal vents. So we're just watching it all take place. And this vehicle is being piloted from onboard research vessel Falcor 2. So in the process so far, we have applied this sealant down to the seafloor where we notice some cracks in the experimental site. And so the next step after we resecure the syringe is going to be placing some sponges, I believe. These kind of offer a little texture, a little surface that we can then collect back up where organisms might settle out of the water onto those sponges, and so when we collect the sponges, then we can kind of see what has settled out. And then after that, we'll be putting another box down, just like the one you see in the background there. That box will then be filled with a dye, or rather another box will be placed on top of it, and that box will be filled with a dye, staining everything that is currently at the site with a colored stain. And when we come back and collect up the experiment after a week or so, we will be looking for anything not stained, anything that has come up under the box through the hydrothermal vent fluid, the water coming up from below the ground. If that happens to carry any organisms up, those organisms won't be stained, and if they settle out under the box, that's what the scientists here are interested in finding.
This one is mixing the number 1.
Number 1 on your side.
Yeah, it's one. Yeah, go ahead.
Okay. You can see here then.
Where are we placing it?
And also along with this chain of sponges that we're going to deploy, there is a temperature probe in there as well, a little data logger that will just record and log the data while the experiment's deployed.
maybe it's good to start with laying the chain like somewhere here, and then around like that.
Okay.
You know that the inside of the mesh box is a bit smaller because the weights are inside it. So it should be really like in the center.
Can I see? Oh, it's on the other. What she's asking for is right here to start the chain right here and then kind of wrap around, but she wants it tight because the inside of the box is narrower than this. So start there. Wrap around.
This deployment of the sponge. Do you have a number? Two.
Deployment sponge tool.
It's a sponge figure.
Yeah. I didn't see this, what is number 2?
Yeah.
Where is the temperature?
You can also. Yes, I think that's good. Bit closer to the crack, probably. If this is like the big. Yes. Like this and back here. Structure.
So once again, kind of proving that sometimes off the shelf can be just great for this sort of thing, right? These little sponges might be something you'd see, or you might even have hanging in your shower, or by the kitchen sink to scrub some dishes. But they provide a good texture, so that little tiny organisms that drift in the water looking for surfaces to settle out on can settle on this.
Slowly move it up because here's the blob.
Yeah, the arm has
Yeah.
lost moisture, so we're fixing it.
Hello to everyone out there joining us. We do love having folks explore along with us.
Okay. Just slowly pick the chain and kind of jiggle it. Okay, we'll have to redo that piece.
Picked up a bit of our adhesive there, but we'll probably have to just reapply that area. It's always sticky on the things you don't want it to be sticky.
Okay. Very good.
I'm wondering if you could just tip the
Probably the tip of the scissor also, because you don't want to like get it stuck on the rough arm.
yeah.
But
Chisel maybe,
with the chisel.
Well, chisel.
I put that in there.
All right, so we have a little chisel on board, we think.
I put them both in there. Okay, we're gonna have to pick up and slide that.
So we're going to relocate a little bit. Just going to use the chisel here to try and get the silicon. I blanked on what it was. I'm going to try and use the chisel to sort of relocate that silicon to where we want it to be there.
I think it's good to stick to it. So yeah, probably let me just dab it in that upper section and like try to pull it. That's what we did to that plastic with the chain. The good thing is if that doesn't work, you don't damage the block too much. Yeah. Maybe we'll have to try something different. Yeah, don't start at the bottom and just try to push it up. It doesn't seem to stick to it.
So some questions about well, I guess these are related questions. We have questions about some of the other material on the chain besides the sponges. This little blue nylon screw, or the white nylon screw through these little blue plates up there. And so this ties into another question I'm seeing, which is the worms. What do the worms like to settle out on? So we're providing a couple different substrates for them. We've got the sponges. We also have the little cube up there. So I believe that's just like a plastic sort of material that can also be used for the tube worms to settle out on.
Very good. It's probably that when you pull these out, it doesn't. It's not a bit afraid that.
So there, in this view now, you can see the two boxes that are part of this experiment. On the right side there, we have the main mesh box. This will be the box that we leave behind, and it has a silicone seal on the bottom of it. So we're going to put this over the site, kind of press it down on top of that caulking that we've placed, and try and get a good seal on the bottom. And that'll sit there. That'll stay there. The mesh will allow the water to flow through, but we'll keep any little critters that might come along with it inside. And then on the left side, just this clear acrylic box, there's actually a tube that goes into that box by which we can fill the box with the staining dye. So we're going to put the mesh box down, then put the acrylic box over top of it, fill the whole thing with dye, wait a while for everything to stain, then we suck the dye back up and remove the acrylic box and just leave behind the mesh box. So quite the deployment, quite the experiment.
Okay, very good. So we'll take the mesh box. It's important again, that's the first time we see it's good. Because we don't want to move around the technique. So
This is two, this is on the right side.
Yeah.
This is here.
okay. This is not now, of course, but afterwards later put pictures of them above.
No.
Not now, no, now I know you're busy.
Okay. Sure.
First floor, up here. This is
Just undoing a little strap here that holds the crate down.
Place it or just let it go.
Yeah. This frame is now.
the closest goes down the side.
So that you also see probably from the top when you deploy it, you see it's easier to kind of see from what angle it is. No, probably that's good for you.
Yeah, it's not bad.
No?
Yeah, this camera here, the
Yeah.
problem is it's so
Yeah,
low
it's,
in our view,
yeah.
it's hard to look down at
Yeah.
anything.
Okay. So I can make a highlight frame.
Torch?
No, the camera.
All right, scientists are just grabbing a few still frames of the site before we begin with the placing of the mesh box.
So we make another highlight frame work. Experiment 2.
One last look.
Good. So basically you need to watch out that they fit in here.
This is for you, Alex.
And then we have, oops, sorry,
No, you're good.
we have an angle of, I don't know, probably 30 degrees or so.
You can dive also that is not
You want me to put a quick reference where the frame was?
They're also passing around some still frames we took earlier of when the metal frame was in place, so you could kind of see how the frame was oriented.
One is sitting
again,
here
is-
and the other one here. And actually the angle itself doesn't, yeah, it should be about like that we don't
Again, that frame was kind of where the box is going to go. It's the footprint of the box.
So it's not touching in the line, and make sure you guys are happy. Plug down nice and easy.
Very good.
We'll start torching out.
Okay. Okay.
Okay.
So basically, it's come in here and hold that handle of the jaws, and just strap them straight up.
I would match the angle,
Yeah.
and I would get a really good grip. I wouldn't go level. That way there's no pitch to the box. And yeah, just try to shoulder straight up and elbow out. Remember that hook stands up 6 inches, so we gotta get it sort of high before we go out.
So since the box is kind of stowed sideways here so that the silicone isn't pressed against anything or exposed on top, it's going to take a little shuffling. So the pilots are currently figuring out the plan. There's a couple different grips and handles on the box.
Keep walking it in. Get as deep as you can without.
Yeah, that's great. You're good. Yeah.
Okay, we'll zoom out. You're good overall. Just go as you clearing the hook everything. Let's do that flip a little more to the right, just in case anything bad happens going on with the sight. I'm going to force back in. If you're ready.
Whoa, that was a bad face. Alright, go ahead. I'm nervous.
Yeah, I would
I need to
avoid
index,
it.
I need to index the wrist of the muscle.
I gotcha.
Go ahead, you should. I'll rotate it from the better angle, that's all good, so that's.
Can you rotate the other way? Yeah. We'll give you like better sit.
What do you think?
We'll continue to force in, give you some space. Yeah, just keep the box nice and low and just keep rotating what you're doing. That's your only choice right now.
You're okay.
I think you're alright.
Think so?
Yeah.
That grip is kind of.
Just get it nice and low.
Yeah.
If you get that corner close, you need to reindex, I think you can.
All right, so you can see that nice silicone seal on the bottom there. You can tell it's a little goopy, so that we can hopefully get a nice seal down to the seafloor.
Don't set that guy's up at all.
Okay.
So the angle slid a little bit, so try to adjust. There we go. What do you think? Go closer to us? So the angle's perfect? Yeah, there we go. Oh man, I wish I could show you more angles, but.
Can I really see to the other side? Yeah.
Pilots are just conferring with the scientists that the angles are looking good on how they would like this box placed. It's not really something we want to put down and pick up and put down and pick up, so.
I think
So this side is in the right position.
Yes.
So we just need to figure out the angles. And I think it might need to go
Like that.
clockwise a little bit more.
Michelle, you see this rock that's immediately
I
underneath?
do, yeah.
Yeah, this one will be better.
Yeah, so that would be outside of the box, obviously. So, okay, you spun it a little bit clockwise.
And it's touching it, so we can
Look good?
put it down slowly.
Okay, let's slowly come down. Okay, just slightly open your jaw. Okay. Happy? Okay. Keep opening. Yeah, it's a little bit stuck. Just bump open.
See what I mean, the part about?
Yeah, if you try pitching right now, you're going to move the entire box. So I'm only hoping that if you keep opening, that will help still.
Hmm.
There it goes. Top down, shoulder down, tight. Medium pitch. Okay, it's down.
And there we go. We've got mesh box down for experiment number 2. And you can see that seal kind of spreads out on the bottom a little bit to, well, give it a good seal.
Yes, we are
And next will be the stain box after this. They're going to kind of scope it out with the camera a bit first. All right, well, with that step down, we're one step closer to the complete deployment of experiment number 2. I'm going to hand the commentary on over to Marine Technician Tyler for now. He'll probably do a recap, a little update where we are for anyone who just came in, so sit tight for that. And thank you again for exploring along with us and for watching, maybe with bated breath, as we're deploying this experiment.
You're like us.
Looks good. Yeah, it looks very good. Looks good.
Okay.
Also up.
I'll go to the other side and I'll land out when we get the
Just a
lowest.
second. Okay. Yeah, but that is wrong. Yeah, okay, so we zoom out. Oops. Okay. can stop here and have a close look on this economy.
Which was okay before, yeah, I think they stacked. Yeah,
Let's see if the
Let this left side first, and then I'll show you the right side.
This is not good. Here. We can, I don't know,
wait 1 second, Monica.
look at the other side. This is basically doing.
So here we're good, but we've been a bit more, not this muscle here. It's right now sitting here.
Yeah.
See? Yeah. And probably it's good because it's, let's have a close look here. Because if it's sealing off with the muscle, it's still fine. But we have to look. But that's no, that's not. No, it's too high. No, we have to move it a bit.
Yeah. Actually, we have to move to go on this.
Oh, yeah. I learned that.
Move it a little bit towards us, no?
No, the other direction.
But you want the muscle out then? Then you
No,
have to
in,
lift it.
in, but we are now
In.
looking from the other side.
Yeah, but
When we are
I
back
think
in the original
if he
position.
stays here, then yes. If he stays here, he just has to.
So I don't know if it's easier. So this box has to be moved like for 10 centimeters towards this direction. So I think the angle is good. But to a bit to us, basically, towards us when we look from this side. Yeah. Can you grab it like land here, or do we have to go to the other side?
That's up to them. You guys comfortable using the forearm and doing it from this side?
If you want, yeah, I don't see what problem.
That's probably what I would do. You see that.
Yeah, you see better what you're doing.
Yeah.
Yeah, 'cause you can see where it needs to go.
And the other side, you already know it's good, and there's also nothing in the way.
All right. Enjoy your trip.
Thanks, guys. This is pretty good.
Oh, yeah, okay.
Thanks a lot.
Thanks a lot.
Thank you. So if you, should say,
This should move it up a little bit and move it like here, that the muscle is inside. So now we look at it like that. And now it's positioned like this. And we have to move it like
You want to
towards
come
us.
mate?
Just connect it.
Yes.
Push it a little bit from the other side.
Yeah, we have to lift it a little bit.
Okay.
Just a little bit, because there's also this glue stuff already on it. So if you lift it, I think for like just a little bit, and then push it toward us like for 10 centimeters, and probably also a little bit to the right here. So in the end, the box this here is ending up like here and there.
Alright, so just a little bit that way and 10 seconds.
Yes,
Yeah.
but just really like so. Right now, you see this muscle. It's below the silica, and we want to have it in the box.
Yep.
Yep. And also here, you can see that probably, yeah. So we're now looking from this angle.
Yeah, so this sort of we're using those worms
Yeah.
as the reference.
So like
Pretty good.
yeah.
You zoom in and
So last time, so right there, everyone from the right, that's pretty much what we're trying to do. Those muscles that you can see at the bottom.
Yeah.
You can size.
Okay.
We just move a little bit up, and it's not. It should be fine to move.
Can you zoom me back in again?
We have to lift it up a little bit more, probably. Tiny little bit. Yes.
Okay.
I think that's. Can you put it down?
If you look at that picture right there, do the comparison to that one.
Okay.
Copy?
Good. Yes. So we have a look there. Then we go around on the other side and look at the other side. Oh, this is not working.
Just get rid of this. Okay. Well,
So the blob is still there, so that's good. Let's have a look here. Sounds good. Sounds good. Okay. So if we can have basically a look here on that side again.
I'll do like 180.
Think it's good?
No.
Why?
I think.
Yeah, but they will push it. They haven't pushed it down yet.
Ah, okay. Yeah, then.
So we just
but
check
the
now, and
location is
then
good.
the location is
The
good, and I
location
think
is
it's also good. Like we will afterwards push it down, and then the black stuff will like, you know. I think that's okay.
How are you today?
Fine. Excited. It's always you know.
Alright, so we just had a watch change here in Mission Control. Dr. Spina Gollner is still on the science mic. We got Chris as pilot, Russ as co-pilot, and this is Tyler on the other mic. So they arrived just in time to reset that mesh box a little bit. Now we're going to flip around the other side and inspect it. Because yesterday we spent time scouting out the perfect place to drop that box, so we have to make sure it is right on top of where the scientists want it. And you notice there's some very soft material on the bottom of that box, so it is going to adhere to the seafloor. Earlier, the ROV pilots put down some adhesive. And if this is good to go, the next step is to put another box on top of this box, and then we're going to flood it with dye and let it sit for a little while.
that's the stressful part.
It's a tricky part, right, Russ?
Well, because it's on an angle, you see.
Yeah, so this is not an easy operation here at the bottom of the seafloor. And so they'll have to set the second box directly on top of that mesh box, which at an angle is going to be not the easiest thing in the world.
This is okay.
It's good.
This is pressed in, no?
Yeah,
But this doesn't matter.
it's good.
This looks also good. I think it's.
You can see the soft bottom of that box squished down on the seafloor. And that dark material it's sitting on in various parts is the adhesive the pilots squeezed out earlier, which is not in frame currently.
Looks good.
Okay, can we look a bit from here? want to have a look at this corner.
Doing a quick spin here so we can check out all sides of this box. Make sure we have a good seal to the seafloor. So when we start pumping dye into it, it won't all bleed out into the water column.
Yes. That's also good. Monica, what do you think? Good?
Did you squeeze already?
No, we haven't squeezed yet.
Maybe the corner.
The corner is, yeah, but that's,
I think the corner
that's
is good.
Yeah.
It's only
Okay, good. Then, this is the final position of the mesh box.
Happy?
Very happy.
Alright.
yeah, great. So this
And then we can continue with the staining box.
Okay. So I'll spin around, Russ will spin around this way, just a little bit.
I think so,
straight on.
yeah, and then that way I've got a view of the angle.
Yep. Just leading straight onto the side.
yeah, looks good.
And I'll keep this backed off a little bit so that there's plenty of room and then
Das
I
schaut
need
gut
to
aus. Wenn man dort drüber ist,
and
schau mal da. Dort drüber ist. So, kannst du von
Yeah, I'm trying to box, like, train all the way
Dort
down.
im Schwarzen quasi.
da runter und da.
Ja.
Also du brauchst nicht sehr weit drinnen sein, das kann dann nicht mehr anders.
Ja.
visual reference.
Und das muss ja bei allen Seiten mehr oder weniger gleich sein. Ne?
I guess these, well, we took the bottom ones off, I guess. Maybe that's it.
Yeah, yeah, actually, that's true.
Yeah, the observation now.
If you want that one.
No, no, I haven't really straight up. Just the highlight of my face.
You want another roll? You want that one? Yeah,
Alright. So. Should have a problem with it over there, but once we get it out, we can move it up.
yeah, no, we got it.
Alright.
Here we go.
Portion.
Well, tell you what we can do first, let's get the budget.
Hold on. Yeah, we're gonna do that arm too. So.
Come my way, it's,
Stay spot.
This is, yes, it is here.
No. Forgot. And there you go.
This is, okay, I should be here.
Alright, and we're gonna watch our portion.
This is so far off. This is not. What is with this side?
Spouts bringing out the porch that contains our second box.
I want to bring my wheel in on that side.
Yeah, it might pull us in, but I don't know yet.
They're working out the best plan of attack for this delicate operation.
This is not the place. Leider, this is right. It's not the other one.
What we have to do, take it off, lay it down.
But this is also,
Right, that's the land.
this is like, it must be some real, like some real here, because this is basically water heat. This is not like,
For one thing,
so I
Yeah,
think
but-
the conversion is.
MRS.
we want to use this a little bit here or not? Because we had to use the chisel before.
Is usually,
Not sure if it's needed, but that you.
this is not.
Just to make sure we don't hit it. Right.
Yeah, that it gets. I don't know.
Sorry, I can just leave it out. I'll just do it. I'll leave it out.
Us.
Yeah, yeah, sure.
You got it. Alright.
And then John probably tells them everything.
Need it.
So, can you give us some- Yeah, yeah, sure. And then the carbon is that stand up,
Yeah.
and they do the conversion.
Yeah, I just put this in there, just
Sorry.
the operation like this.
Okay.
And then just.
No, that's not good.
Flush it.
See it?
So the pilots are clearing out any obstacle in the way of that second box, taking great care to make sure it can be fitted on top of the mesh box undamaged. Taking great pains to load it on the porch and launch and recovery in every aspect of this dive so far to protect those two delicate boxes.
Alright. Hold it there, I'll push in.
Yeah.
Off that bar.
Yeah, coming out, coming out.
Alright.
So I'm wondering if we should try actually using the rope. Or just leave this. 'Cause I'm not getting very good about it. Can you pan up here?
Yeah. Just one second.
I have it, I put it in the.
We have enough weight.
No check.
Anything else you have, I should flip a little bit more.
Well, just see what we got there actually. Yeah, we have to come ahead.
Yeah.
There we go.
So a little bit more now we have it.
So this is not, the point, no? This is 50.
This is 50.
Yeah, I just put it in. The other one is
Right, the side lower is
71.
bashing, I think.
Yes, if you
Hold on.
I would just say, okay.
Wow, get out.
Whoa.
Sorry. It's a distracted. I see this. Alright, what is it?
So you may notice this second box has a tube attached to it, and that's running to a pump that we will use to put dye in this box. So there's a limited reach on where the second box can go. So the pellets are flying forward just a little bit to ensure they have enough slack line in that tube to set it on top.
I'm gonna be struggling to reach that. James not be using it.
I don't want to land on the frame. I do not know. I don't think that it's time to go trade, but I don't really know the answer.
I'm gonna try to. Alright. The angle's a bit off, so I'm gonna try the rope.
Yeah, go for it.
Straight leg on here.
He's going to grab the rope.
But with the rope, can you like, because it will swing? I'm not sure if the rope is better.
No, I'm not. I can't get the right angle.
You can elbow down and shoulder down. Hold on, let me see about the portioning. I have no idea. Yep, so you let's push this off though. So it's a 6 of 1 half. Okay, stay there. I mean, or meter from it.
Okay.
What do you want to do?
Well, I don't have a good angle. That's the problem.
So what do you want me to
I'm
do?
gonna have to leave there. I'll have to leave there. Because I can't get high enough. If I go too high, I've got the wrong angle, so I can't drop on the top. So I think I'm gonna try that. If we have to, we use
Yeah,
it, but
so
I'll
if
have
you
to
can
continue.
put it down on the seat and then get it to rope.
That's what we're doing.
Yeah. Yeah.
Can I see the arm, please?
Just remember you gotta get it off of there on that box. So. Alright, could be on the sit. Could be on the sides. Zoom in.
No, I'm good to go. Let's get my unit first.
And we'll do your shadow, a little bit go. Alright, this is clear. No, this is good. There you go. And back away from us. Back back away from us.
No, it's so that's saying this one.
Into that angle, get that left side out first.
So downward a bit is if you use the rope, because the angle of the box is a bit like that. But of course the box is like horizontal. It's a good problem or not?
Well, you should be able to lay that down.
Yeah.
Every time I freeze it, it just jumps.
Try activating it to the freezing.
Mom's in a really bad position, you know. Who's all looking for coming in?
Let's go back a little bit. Try hitting that.
I know about you, I know, I can't do that once.
Right. That should be good. Farther away. A bit more, nope, not yet.
I mean, you do that. It's okay, I'm looking at it, just need to reposition it. So,
Shadows.
Yeah, I think the rope tangling the box doesn't necessarily make it easier though.
This one for
The angle was
stable.
here, you have the problem, tangles a little bit.
And also if the angle a bit, there's both the angle and the tangling.
Like it's
Coming down the side would be make it easier to control. Like I don't know if you can route it or not. I don't know. What do you feel about what feels that way? Is that maybe? I don't know.
Or like really pull it up, you know, like not close it, but like,
Like in the jaw.
yeah.
Yeah.
it is.
On the left hand side. That way you don't have to close the jaw on it. You just like this.
it's not got any control. Well, I can give it a shot. Zoom in.
Yep. And then if you get a good deal of stuff, establish the show. That's too much.
Well, but
Yeah. Yeah.
okay, that's maybe okay.
There you go. Alright, just look back away. That's pretty good, left to right.
You're gonna have to open the jaw for it.
Not from. bit more away. So you're gonna angle, go a little bit counterclockwise to the box. You know what I'm saying? There you go.
See it.
Yep, you're on the thumb.
Yeah.
Got it.
A little bit down, just a little bit. And you can let it go. You can let it go. You can let it go.
Yeah, but on the side, you see, it's not easy to do it that way. Just hold her up as low as you can.
But all is good. Still good. It's good. That's all good.
Alright, if you want, I can push it on the box itself.
Yes. Just, I got you.
Ah, it's
Hello.
Alright.
Well-deserved round of applause for the pilots,
Okay.
especially Russ with the stressful job of setting that
5 years up my life.
box on top of the other box.
Sorry.
I should have a few more.
Tough job.
okay. What we want to do now is to press the box a bit towards the bottom. So
Okay.
last time we had like both arms,
Yeah.
like this.
Would pressing in the center be okay, or do you think?
So like one and here the second stick.
Yes, I do.
Basically one arm here, one
Sorry.
arm there,
Yeah, yeah.
and then press it down, and then afterwards potentially also press
Okay.
it.
Is that idea?
Stop for me. You ready?
Yeah, okay. Okay.
Very good. Yeah.
Alright, I'm gonna go to the right.
But I think it's fine. I think it's fine. I think it's good enough.
You
Yeah.
good?
Yeah.
Just check it.
Okay. She's all good, they're happy.
I think we have it. We just check the bottom.
I mean, at least as far as we can see. Yeah. Yeah. Yeah, all good.
Good, this is as far as we can see good.
Alright,
Okay.
they're only bees, they can't fly away.
Okay.
Okay, and then staining.
Staining.
Ready?
It's the time.
Again.
You want to turn that camera on for your jaw, you might maybe, and then there's one more view for this, or
It's 3 and 4 hundred.
Probably you can also make a highlight.
Good morning, evening, afternoon to everyone, wherever you may be in the world tuning in. What you're about to witness will be pumping the red dye into the apparatus you see there. So there's the mesh box underneath, and then we have a cover on the outside hooked up to a pump, which you can see there. And one of our esteemed ROV pilots, Russell Colefield, is about to turn on the pump, and you'll see a red dye coming out. So don't be alarmed. It's not
No, first
anything.
it's the lower.
Sorry, it's not. It's not blood. It's just going to be a red dye, so that's easiest to identify when all of the organisms that are in there, if they are dyed red, when something new comes in,
in a few days, and we'll be able to determine that it was not from the original group.
Biological observation.
4 inches.
Sabine,
One second.
biological observation for start button.
What?
Should I record a biological observation for start from the pulse?
Yes. A little bit more. Yes, very good. And now switch the power on.
Yeah, I'm recording now.
And it's already running, so it's on. So the time now is 10:57, and we set the alarm for 35 minutes to pump the stain in the bag. Yes. So 35 minutes. Timer starts.
Can you go to this?
Yes. We go to the camera.
No issues. No. Next it could be like low air or something. Maybe it's wrong.
No, it's still okay.
Oh yeah, it's expanding at the top.
Yeah. Okay, then we switch on off.
Okay. I mean, it's still moving at the top.
Yeah, I'm not sure. But it's still. We wait a little bit.
No, but it's not.
No, I think. Let's wait. I think it's still moving. Huh?
Yes,
It's still moving. Yeah. Yeah. Also here you can see it expanding, and also it's going down. Just wait.
Yeah.
Actually, the pipe box all clear.
Yeah, it's moving now. All good. You can see it.
But it would move right by itself also without giving.
Yeah, but not in this. You know, you can.
Go on the down.
It's going down also. Yeah. Yeah. Okay. All good.
So in the top right corner there, you can see the bag that contains all of the dye.
Now we have to
So it's
stay
going to
down
take
there.
about 30 minutes for that
Because we can see
to
where it
fully
comes
pump out.
First, and if it comes out below.
Just hold it down.
And the pilots did quite a thorough job of ensuring that there was a good seal with the substrate here, so that we're not going to get any dye leaking out of the bottom. But this stuff is pretty potent.
What was that? Stephen Miss
Carry.
Carrie as well. Yeah, Carrie.
Or it.
It.
Red balloons. I was thinking of the this is still coming in.
So from this angle, you can really get a sense of how concentrated this dye is. So that will permeate pretty much everything that's in there. And we'll let that settle in and stain everything that's contained within that mesh box over the next few hours. But luckily, there's so much going on down here in this area that there'll be plenty more to look at while we sit stationary waiting for the process to complete. But
That's also good. You're not here, yes.
Less than the
No, it's not down yet. Not fully down.
coming
No,
out
it's
on
coming
this
on this
one.
con.
This is exactly where it should come out.
so there's here you can see there's a little bit of the dye leaking out of the bottom. But in order to be able to lift the cap off at the end, that can't be fully sealed. Otherwise there'd be too much suction and we just tear the thing off of the seabed. So a little bit of leaking is fine.
Yeah, it's not.
And being that we're at the top of the hour, I believe it's appropriate for a station ID. You are watching a live stream from ROV Sebastian, which is attached to the research vessel Falcor 2 of the Schmidt Ocean Institute. We're at the East Pacific Rise, and we are off the coast of, we left from Costa Rica, but the nearest landmass is going to be Mexico.
Ja, da unten ist nichts. Das passt.
Das war schwarzes Weg, ne?
That's good. Perfekt.
Unten schon praktisch das Reiten.
Oh, da ist mir nur sauber. Yeah, it's fine. Sorry? The pump is working, yes. It's like going down slowly, but it's good. You can still see like it's going down here. Yeah. It's going out here and this. Oh, it's good. This is the little slit where it's like coming out again. Here it's sealed.
It must go out somewhere.
Yeah. It's good. Yeah. That's how we made it.
60 meters, it's going to be 2 times the same position.
Okay.
That's very appropriate to the this work. Really, I did install this. There you go.
Okay, we'll zoom out a bit. Other direction.
It's actually quite good if you're on a slope like that. I can go down, right? That's actually what we're doing.
Please, can you zoom it a little bit here? You see, now as we do, we must put 2 holes here,
Yeah.
with the edge because it's like broken, you know. Here and here.
Ah, yeah, I understand. Yeah.
We must fix it.
Yeah.
This loop because can
Yeah.
next time we broke it.
Yeah.
Ja, das ist.
Okay. Broken. So this zip. 2 holes and zip. Yep.
that seas become red. blew his trumpet and something like a great mountain, burning with fire, was thrown into the sea, and a third of the sea became blood. The apocalypse.
Yes, interesting.
Yeah. So,
Interesting citations.
On the one side where it's mounted on the wall, it's going down, take it. It's like, that's fine, I think. Yeah. Schauen Sie es mit dem Diameter gut ausgeht. Also es geht ja aus, aber das muss man checken. Okay, and back in gerne gewonnen. Bis jetzt mit der Regelung, wir schreiben dazu, wie
All right, and if anyone is curious about where in the world we are at the moment, we can have the Google Earth view here. We'll zoom in. We're at the East Pacific Rise, and this is Sebastian's 547th dive. Zoom out a little bit more and give you some context here. So the nearest point of land is Mexico, and then the rest of Central America, including Costa Rica, where we had left from. By the rest, I mean including Costa Rica.
Yeah. Yeah. It's possible to find that window with 100 diagonals and second that.
When?
Is it possible to see like that 100 diagonal with the 200 diagonal?
I'll also give you an overlay here of the bathymetry of the area that was collected on a previous expedition by AUV Sentry. If you can see, if we zoom in a little bit here, down to the seam that Sebastian is currently sitting within. And that thin gray line that you see there is the position track of Sebastian on the descent. And then we've been largely working in this small area here. This is somewhere that we've returned to. If you've been joining us on our previous dives for this expedition, then you'll recognize most of the riftia that are here.
You know, to repeat from you.
But you have to cite them all.
There is this audio.
under your hosting.
I like the light. The camera.
This is your own logo.
I don't know why the picture didn't look so.
Don't this text anymore.
So you don't want it?
This text, no.
No.
This is,
I
it's like you don't
I
know where it
did
comes
it. I did. So you don't want that.
from. Text of the word.
Yeah.
This is, you can actually.
Yes. Oh. Is that fun? Yeah.
Looks good.
Everything on the plan?
Yeah.
Just like it.
No, we're not.
It's really similar to the cyber ocean.
Oh, I mean, I just showed you a message. Of printing.
Yes, it's good. It's fine.
Sorry.
No problem.
Okay. I just.
And we had already two good pictures. I just wanted to have some more angles for it was fine. So But we have like 8 more minutes, so we'll see how the bang looks.
That was a long time ago. Just do it properly. That's right.
Not today, but this is when we were back in Fiji.
That's what it looked like, isn't it?
Yeah.
It's not good.
I'm really happy that we also made the frame to check the sides. This we decided how late to have. We designed all the experiments to take the frame with us back to Midwater. This was a rather late decision, like when we bought anything food. It was really crucial. But you cannot see the, the angles. It's body. Minutes. Yeah.
ROV bridge.
Go ahead, Rich.
Okay, I'm just going to change our heading 15 degrees to starboard just temporarily for AVIT, if that's good for you guys.
I won't bother us with it. Go ahead.
So, two kinds of type. Probably have a bit more time to also like look around the place. The technique is probably, I don't know if like überhaupt, ja. Nur dass man wissen, überhaupt.
So, as you may or may not have heard on the radio calling down from the bridge there to Chris Ingram, our current ROV pilot, one of the officers was requesting permission to change the heading of the vessel of RV Falcor 2 for a little bit of testing with the VSATs. So currently we're streaming to you by way of low Earth orbit, internet connectivity, and we do have VSATs as well. So we are in a relatively remote area, and the footprint of satellite coverage for that service isn't optimal at the moment. So I'm just going to try moving around a little bit, and hopefully, if anyone at home is experiencing any buffering on the streams that we've been doing the last few days, the AVIT engineers are hard at work to resolve that issue. So rest assured, we are working to make this as easy for everyone to view and participate as possible. You can see here that how much dye is in the box there. So it is kind of seeping out and going with the very light current that we have down here, but and that's in the foreground, obviously, the one we're pumping in. And Chris is moving the camera around a little bit better for us to see. Get a nice shot there. And then in the background there on the left-hand side of your screen, you can see the mesh box that we put down 2 days ago. So that was the exact same setup as we have here. So you can see the dye will settle and soak into pretty much everything that's in there. So we also will be expelling the remainder of the dye when we ascend back to the surface, just to reduce the risk of having yellow Sebastian turn a kind of strange orange color with all of that red dye getting everywhere. So if you are watching us on the Ascent, if we do some of the blue water streaming, don't be alarmed. It is not it's not anything bad. It's just pumping out the non-toxic red dye so that can disperse and be diluted in the water column.
Yeah, it stays pretty good.
Yeah.
We can close the pump in like a minute, so if you want to get ready.
All right, so we've got about a minute left of pumping. You can see the bag here is quite a bit more deflated than it was when we began. And Russ Coalfield is getting out our starboard manipulator. I'll get a nice overhead shot for you here, and you can see just how it is quite difficult to maneuver around and do all the fine motor skills required to operate the pump switches and everything, but not that difficult for a seasoned vet like you, eh, Russ?
Yeah.
Season. So he's for it.
There we go. That's been 30 minutes of dye pumping. There we go. A couple of redundant alarms there.
So we can.
Not unlike everyone setting a few alarms to wake up for our 24-hour ops here on board.
Put tension on the cable on those a little bit.
Very good, thank you. And now we wait for 3 hours.
Okay. Yeah, I'm back.
Yeah, this is where the fun part begins.
Is it possible that you put in the map some coordinates so we see where it's located?
Sure.
Because it's one of the coordinates in Schmidt.
What's that?
I'll move that one.
If you'd like,
Yeah,
no, something
yeah.
happened in degrees,
Sure.
minutes, seconds. So I
This
can
is exactly what he did. If you try to do maybe just not convert in right, or you did not convert right.
handle right. I'll do it over this screen. That's a big screen here.
Right one. Right photograph.
Dann setzen wir uns rechts an mit Stunde gehabt und dann quasi nur die halbe Stunde das auch schon noch dazu. Dann noch sitzen gehabt, quasi 3 Stunden, genau, 2,5 und dann die anderen dazu. Das heißt, es ist dann um 2 Uhr. Jetzt ist halt praktisch jetzt sitzen wir. Das wäre halb 1, halb 2, genau. Dann fahren wir noch 2,5 Stunden. Genau, also nur 2 Stunden haben wir, weil es muss ja noch zurückkommen wieder. Also 2 Stunden haben wir.
Not the best thing that could have happened today.
Das ist noch gelogen, aber ich schaue mal, was ich jetzt
Wollen beide vielleicht da sammeln und dann, oder einfach aufnehmen, schauen, wie spät das ist. Und dann
You may never know.
I know, one of these things.
schauen wir.
Monica would be,
Also wir kommen auf eine Aufnahme so schnell. Das letzte Mal sind wir von Tika nach Island, sind wir ungefähr
it's about 180 meters south of us. So, yeah, so about 180 meters.
I can't help it. Every time I look at them, I just think crab legs.
Sorry?
So I can't help it. Every time I look at them, I just think crab legs. Instead of like seafood and everything.
Put it to the decimal degrees. Yeah, it's unfortunate. It's right when I had to run off to speak. Those are my Canadian European ones. Yeah. And then we'll take off today. Yeah, it's not great. It's only 180 meters.
I can get you see possible. You feel that system.
Chris, do you mind if we get a little zoom in on the box from the other day and just to kind of compare and see the difference between the two? Thank you. So we'll be going through some venting fluid there. It's the shimmering that you see in the water of the extreme temperature differences. Currently, sorry Russ, mind if I... Yeah, so currently the ambient temperature down here is 2.5 degrees Celsius, or 2.4 rather, sorry. And then the hot vent fluid coming out, so that's the shimmering that you see there. So it's kind of difficult to see the old box, but certainly you can make the distinction that it's a lot less dark than the one we're currently staining. So the one we're sitting and waiting for the stain to settle will look like that when we depart today. It's in a pretty stark contrast to, if we zoom back out a little bit. Right there, yeah. So a lot of settling for the dye to do. Hence the 3 hours that we sit in position here to ensure that everything goes to plan. Takes quite a bit to get down here to set up these experiments, so 3 hours may seem like a long time to sit around, but it's well worthwhile to know that everything is going exactly as expected.
My sister being is asking, what is that? Box of blood. What are you doing? She wishes good luck.
Salve, would you like to sit on the mic for a while?
Like that?
On español?
Is it okay, Monica?
Sure. Yeah, I go for lunch. I go for lunch, then if you talk a little
Feel
bit.
free to use the camera as much as you want. So it's like, that's down, that's up, left, right. That'll zoom in, that'll zoom out. Okay. Hola, soy Salvador Espada y estoy a bordo del buque oceanográfico Falcor 2 del Instituto Oceanográfico Schmidt Ocean Institute, y estamos con el vehículo operado remotamente Sebastian, pues en la cordillera Albatros, a unos 2.500 metros a unos de profundidad, y creo que son, no sé si 2.000 kilómetros hacia el oeste, alejándonos de la costa de Centroamérica, Océano Pacífico adentro. Y estamos haciendo unos experimentos al respecto de los gusanos tubícolas y de la fauna de las fuentes hidrotermales. Aquí la cordillera Albatros es la cadena montañosa más larga del planeta. Recorre pues casi desde la Antártida hasta Alaska, atravesando el Océano Pacífico de sur a norte, y es la zona donde se forma la corteza oceánica, donde se forma, digamos, la capa dura del planeta. Y esto ocurre en todos los océanos. Los océanos es donde se genera el suelo del planeta, y esto ocurre pues en forma de una cordillera volcánica que continuamente está sacando suelo nuevo, el magma, y esto es justamente eso. Y aquí donde se ve en la imagen el agua como un poquillo borrosilla, eso es porque el calor del interior de la Tierra está saliendo en forma de flujo caliente. Estos gusanos que se ven en la imagen son los gusanos tubícolas gigantes. El nombre científico es Riftia pachyptila, y utilizan la energía que emana de la Tierra, la utilizan para hacer quimiosíntesis. Tienen unas bacterias dentro de su cuerpo que hacen esa quimiosíntesis, convierten el anhídrido sulfídrico, que es como el olor de los huevos podridos, ese gas que está emanando desde dentro de la Tierra. Les proporciona la energía a las bacterias para crear materia viva, similar a lo que hacen las plantas en la Tierra usando la energía del sol, pero en este caso es sin usar la energía del sol, sino en vez de eso la energía química de los compuestos de azufre. Y este gusano tubícola, Riftia pachyptila, pues vive en simbiosis con esas bacterias y las alberga dentro, y les proporciona el oxígeno y el sulfídrico, y las bacterias crean biomasa que alimenta también al gusano. Y tenemos el misterio de las larvas del gusano, cómo colonizan nuevos lugares, porque el flujo hidrotermal emana de estas grietas. Entonces para la larva sería muy difícil nadar contracorriente en contra de ese flujo, y la profesora Mónica Bright, catedrática de biología marina de la Universidad de Viena, que lleva estudiando estos animales pues varias décadas, ha acuñado la hipótesis de que las larvas, en vez de nadar contracorriente buscando los lugares de emisión del fluido hidrotermal, lo que puede pasar es que las larvas son liberadas por parte del gusano padre y madre, y por parte de la madre, del gusano madre, y pues como que nadando un poquito alrededor sea succionado por el fluido que entra, el agua de mar que entra por las grietas, y al entrar en el subsuelo el fluido se calienta y vuelve a salir por las zonas de emisión, y que este sea el camino que las larvas del gusano tubícola encuentren para llegar de esa forma indirecta a través del subsuelo a colonizar los nuevos sitios de emisión de fluido hidrotermal. Y para averiguar si esta hipótesis es cierta, pues Mónica Bright y Sabine Goldner, que Sabine Goldner es investigadora del Instituto Real de Investigación Oceanográfica de los Países Bajos, pues han diseñado, en colaboración también con el Instituto Nacional de Biología de Eslovenia, han diseñado este experimento, que son unas cajas, dos cajas una dentro de otra. La caja de dentro tiene una malla que que puede pasar el agua y puede pasar los líquidos, pero no pueden pasar los animales. Y la malla de fuera, pues de plexiglas y es la malla para la tinción. Entonces lo que hacemos es teñimos lo que está dentro de la caja durante 35 minutos y así todo queda a color de rojo. Ahora recuperamos el tinte, lo volvemos a meter en la bolsa que tenemos aquí en el Sebastian y todo lo que ha quedado dentro de la caja, que estaba dentro de la caja, está ya rojo. Y ahora dejamos la caja 11 días. Y a las 11 días, cuando volvamos, si encontramos un gusano jovencito nuevo que se ha sentado dentro de la caja y que no es rojo, que no está teñido, pues no tenía más manera que de haber entrado ahí que por debajo, que por la grieta del suelo. Y esa sería la manera de probar que utilizan el subsuelo para colonizar las nuevas fuentes hidrotermales. Y aquí estamos, que nos ha financiado el Instituto Schmidt Ocean el uso del barco y del submarino, y estamos muy contentos de poder hacer los experimentos aquí con un equipazo de pilotos y de ingenieros que tienen una habilidad que es impresionante y una tecnología también muy imponente, con la cámara esta de 4K que saca unos detalles para hacer zoom que es también muy bonito. Y bueno, también hay una estudiante de Costa Rica, Ivonne, que hace también emisiones en castellano y nos cuenta las cuestiones, así que de vez en cuando estaremos hablando en castellano. Tenemos como yo creo que este es como el quinto, tenemos como 13 días más de inmersiones. Y de vez en cuando pues estaremos hablando también en español, así que permanece atentas y atentos por si os interesa, y cualquier cosa que queráis plantear por el chat, pues también estamos encantados y encantadas de contestaros. So this was my speech in Spanish.
Salva, you're from Malaga, right?
Yeah, I come from the south of Spain, in Andalusia, which we have sea, and we have also heavily researched area. The Alboran Sea is thought to be the most studied area in the planet, and we have cold water there because we have an upwelling, and I like to swim there in summer in the refreshing water.
What is the sea called?
Alboran.
Alboran Sea?
Yeah, it's the Strait of Gibraltar.
Ah.
And it's historical, the end of the world for the Greek culture. Finisterre Cape is in Galicia, but the columns of Hercules are thought to be Gibraltar and Tangier. So this is deep in the Western culture roots. Yes, Malaga is just here. So Malaga is the biggest coastal city of Andalusia, like 500,000 inhabitants.
Got it insert up on the screen there for you.
Yes, yes. It's also a very ancient town. It was founded by the Phoenicians 3,000 years ago. So it's a long history and nice place to visit.
You said it gets cold there sometimes.
Well, we have mountains. We have a mountain range that on the north, so we have a special microclimate. So we have tropical, subtropical climate. All this coast at the south of the mountain range is really special place. Also heavily colonized by the tourism, like especially the coast of Malaga to the west, much constructed, and a lot of environmental pressure there, and environmental problems, and yeah, all the challenge that we have in the planet.
Me?
Yeah,
New Mexico.
New Mexico.
New Mexico, just next to Texas. Very similar, a little bit drier.
Yeah. You don't have a coast, access to the coast.
No. And now I'm in Ohio, which is quite different.
Hmm.
Not hot at all, really. That's a pretty crab, huh? Very pearlescent looking.
Yeah.
Taking a little,
Tiny well there.
little bath.
Little spa day.
Yep. Hot tub.
You notice the crabs here, they seem like they're a lot cleaner, like their exoskeleton hardly has any stuff on it compared to the vents in the Atlantic that were just covered in stuff. Remember Gandalf? I felt the long furry stuff on him and everything.
Were the same crabs, this Vitograya in the Atlantic?
I don't think so. They didn't look quite the same, but I don't know. I'm not a crab expert, but they looked a little
He just
different.
gets crabby in the morning.
I just get crabby in the morning, that's all. Wah, 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 wah.
Rift you okay in the corner there.
What's this guy doing? Looking for food?
Maybe enjoying the warm water bath.
It's got to be a pretty good life for something like a crab here, you know? You just soak in the warm water and eat all the stuff you want, and
Spa, yeah.
no problem, you know?
Picked up on that worm in front. So unfortunately, we didn't get to go down to Malaga, but during the entire refit of Falcor 2, we were in Galicia, in Vigo. So I think I speak for everyone here. We miss Spain quite a bit.
Oh, yeah. Yeah, Spain was great. Very impressed.
Te amo España.
I thought I was going to like it, and I was still pleasantly surprised.
And you had to supervise the refurbishing of the.
Yeah, pretty much everything here, all the cables. But the shipyard did much of the physical work. You know, we had contractors in to pull cables, but it was a busy time.
And
But
you were in the classic Falcor for several years, also
Yeah.
operating it.
Yes, yeah. Russ was one of the people that helped design Sebastian.
Good to go. Yeah.
Wow.
You can blame him for anything you don't like. Oh, yeah. Here we go. What's not to like? Well, like shimmering water here is just everywhere you look.
Caliban.
No spots without it.
We can. I mean, the summer PC.
Oh, there you go. You got a channel through here. I mean, I actually quite like this. It gives you a bigger.
Yeah.
Sweep down this kind of stuff as well.
The slugs are pretty also.
Oh, excellent. Maybe they had success with the test.
Seems to be.
That bodes well for the rest of the.
We want to hit this on.
Yeah.
So this is our 1 meter. This each of the pixels of this.
I believe so. Is that right, John? 1 meter resolution on those pixels?
It depends on how far you're zoomed in there. It should say at the lower right. Yes, 1 meter for you guys there.
1 meter.
On the Copilot screen, it's 10 meters. It's a little tricky to see with the color map of the bathymetry. You see grid size, 1 meter.
Okay.
And then, of course, if we zoom in more, still 1 meter. Now 10 meters there.
And this you developed also this
No,
navigation.
This is third party.
Third party. That's very beautiful. Navigation things.
Green Sea. That's cool.
Those are related to the Rifty, I believe, they were saying the other day.
Sepulveda.
Like,
Also polykits, I think.
They look like they'd be pretty good for cleaning up the dust in your shelves.
or filtering the water. Feed on.
Keep your pill clean.
Yeah. Train those muscles. Is that a stock on this one? I'm zooming in on the one on that.
Unfortunately, Max, but I see one here that's a little different. Is that what you're talking about?
It does look like it's a stock, is it? Yeah, I was thinking this.
Oh, look, I think you scared him.
No, I was thinking this one here. Yeah, stock comes up.
Oh, yeah.
Is there anything else in a little closer field of view we can zoom on?
Is we snail
There's a little snail on there. He's on the move.
He's like running away. Man, that was weird right when I got near that guy. That's the second thing like I've had today. I'll have to tell you about the little later.
Good sense, yeah.
So these guys I might be able to get a little closer on, maybe. They're quite small though, is the thing, you know?
Yeah. It's good, that good too.
There's something there that's stock.
Yeah,
Or is it?
stock, yeah.
Maybe it's not, maybe that was, no, that's coming out of the actual tube. So it must be something, and that was the one too, it must be like eating. There's more of those snails there. You see that snail just to the left with the
That guy's cooking.
almost little spiked back. Little red polychaete there.
Snail stores.
Snail
Stegosaurus
stores.
snails.
Pretty neat.
Andrea, you want to hop on the mic? Introduce yourself. En español or inglés, your choice. Oh, sorry, Portuguese.
Whoa.
Uh-oh. Uh-oh.
You better get beat up, John.
Yeah, that's it. You better not say lo siento. 1.5 meters. I call it Spanish. Worse than calling you guys Canadian. It's all yours.
Do it. Anything you know, anything you
Alright, yeah, well, we're still for the next couple of hours. Seem to work quite well. If you come in behind like that, it gives you the match. So you can go into the angle.
You get the handle rather than the rope.
Yeah, the rope was just, there was just no control. Yeah. So just by having it loose like that worked pretty good. So this is something I think of next time.
far in are we?
I'm just starting.
Okay.
Try to raise it.
All right. Well, keep that in mind throughout. Now when I hand it off to you.
Yeah, yeah.
Okay.
Anyways, thanks a lot.
Yeah.
You're welcome.
You're from Portugal? Sorry? You're from Portugal?
No, much better.
What's that?
No, I'm from Brazil originally.
Oh, Brazil?
Yeah. But I've been to Portugal many times because I live in Europe, so it's really good.
Where in Brazil you from?
São Paulo, São Paulo State, a really small town.
What town?
It's called Jabuticabal. It's like, yeah.
What's up? There's some interesting names of the cities around São Paulo, so I was curious.
Yeah.
So 'cause there's like some have like Greek names and like almost German sounding. You know what I'm talking about? Like some of the cities have like the cities are also
Yeah.
like, and then, like some of them have like Greek sounding names.
Yeah.
Like German sounds, so I was curious.
Yeah.
So it's awesome.
Never been there.
No, I've only been Rio and North.
Okay. Rio's really nice.
I went to Victoria a lot. It's really nice too.
Mm.
Awesome. That's my crank in the back down next year.
I guess I'd have to look at the cruise schedule. I don't really know off the top of my head.
That's your snow prices.
No. No, too busy alphabetizing blank paper.
Yeah, that's right. Well, you're not going to do that next time, I guess.
Which would be another reason I wouldn't look at it.
That's cool.
It's the 8th. 7/8/23. Should be a cool little panel, hopefully.
What's going on with that holster?
What's that?
Just show me what's going on with that holster real quick. That's you, Kendall.
Oh, you're talking about the HD plug?
That way. Yeah, that whatever you got. Oh, you're doing another guy.
This real quick.
Never mind. It's not that important. I was just curious to see.
I think we
I'll
should.
make that. Like, oh, where you go?
Yeah, that's what you want.
Is there a stock Manipulator in there or something? Oh, that's the. Doesn't matter. That's kind of what I was looking for. Just so much how I got that it was.
Some small tools were in there.
Look at the animals. Look a little bit at the rocks. Sometimes they're more interesting than you might think.
See that?
That's easier. It's almost, I wonder what this lighter stuff is. Is that a mussel shell?
Yeah,
That's where we wreck house.
destroyed.
It's very much like an obsidian kind of thing, huh?
Like Kynoderm here.
Yeah. Oh,
Cool.
Brittle stuff.
Yeah, yeah.
I saw a bunch of snails a minute ago too.
Mm-hmm.
Is that stuff that those mussels put out? That stringy stuff? Is that what that is? Well, there's a bunch of kind of germs. Those ones are feeding there, huh? In the back.
Yeah.
I think when they raise their arms up, that's what they're doing, right?
This was even the wrong one, so I need to write something to write.
Okay, so it's
This is this has launch coordinates already for tomorrow, so I have to send it back.
Yeah, you can sit here. That's fine.
You changing spots, Monica?
Later, yeah. But I just
Tomorrow?
mess up with it. Well, we want to go, if we manage on this type already to go to this site, this is like this here, not this, because I just got a correction. I need to correct also the
Is that group that was
further up.
way north?
Yeah,
here?
but it is,
These guys, teddy bear?
yeah, right, but there's two teddy bears. So the teddy bear that is published and the teddy bear of Stefan Sievert. And we want to go now to this here, but my launch, so my tomorrow's launching coordinates were, he just corrected me also because he found in his own mistake. So it's like 9.
If you're just joining us,
This is where we want to go now.
this is the Underworld of Hydrothermal Events expedition. These are live images coming to you from ROV Sebastian, which is currently parked 2,514 meters down on the seafloor on the East Pacific Rise. So we're in the midst of a lengthy experiment here today. So what you see in front of you is actually two boxes. There's an outer box and an inner mesh box, but they're filled with dye. And we're going to let it sit here and stain everything in that box for another couple of hours. And so what the scientists are looking for is we're going to stain everything in this box. Then we'll pull the outer box off, leaving a mesh box like you can see in the background. That's a previous experiment. Then when we return to this site, if anything that is unstained has moved into the box, we know they have moved there since we dyed it. So one question the scientists are looking to answer on this expedition is, do tube worm larvae and other organisms perhaps, do they travel through and underneath hydrothermal vents to get to the seafloor? So rather than swimming from place to place, do they actually go under the seafloor to get to new areas? Because this is part of answering that question. So the dye is going to sit for 3 hours, so we got another couple hours to go. So we got some time here on the seafloor. Our principal investigator, Dr. Monica Bright, is working with Zach, one of our pilots, to check some waypoints. And yeah.
Yeah, it was much more narrow than this here. Where is the places, and you could see most beautiful movements, and I said, I want to go there. But we could not. And I don't know how it looks now. So
That's cool. What's diverging? Should we make it big?
Maybe a couple of mil. Pretty fast. At least look weird, huh? All you gotta do?
need to convert a little more in because I'm just saying this is the real teddy bear. This Yeah, this is the real they found over there. But
It's called teddy bear anyway.
fussy bacteria, like a teddy bear. I don't know. And I will take a break.
Nur a few starting in the coordinates.
We're gonna have to convert those in decimal or in degrees. What format do we need the coordinates in?
The ones that's a decimal.
Decimal degrees, minutes, seconds, right?
It's not reason.
Yeah, but if you give it to John, John can do that. He can probably do that instead.
Yeah, he did this one, but
Okay. Oh, is this a new one?
yeah, this is was in his thinking.
Okay.
He did this one.
Oh, okay, so that's.
We'll give that to John. Speed good. Maybe there's not one you can just do one. Yeah.
Yeah.
I think that's.
At 2 o'clock it starts. In the time.
That's not right. 9.8416666.
Somewhere else.
So hold on, I'll make a new thing.
I think this is right.
Avoid commissions, okay, so I'm gonna do.
Can you read what is this? This is one.
Alright, so what is it now? Nine
You
point
want to
what?
go further north, I guess.
Is that a 1?
I will go to this thing. How late is it?
Okay, so I got 9.841.
So up on the screen now is a little bathymetric map of the area. You can see RV Sebastian in this little bit of a canyon here on the East Pacific Rise. But it'll give you an idea of the topography around us that is off camera that you can't see. So we'll do a little bit of rotate so you can kind of get a glance at that.
Sorry, 291.
So from a higher vantage point, if we had unlimited line of sight, that's kind of what it would look like down here on the seafloor. That yellow box is a representation of Sebastian, and what looks like sort of a tangle of fishing line around us is actually the trail of where the sub has been marked as moving around the seafloor. So the cool thing about this particular experiment is these deployments you see on the screen currently are the first time this experiment has been tried on the seafloor. So the science team previously tested it out, and they said about 3 or 4 meters in ideal conditions, so flat surfaces. And so this is the first time it's been tried in the deep sea, and they're happy with both deployments so far. If you tuned in on our previous dives or earlier today, you could see that it's quite an arduous process to get this experiment set up. It's a multi-day process. It involves the scientists picking a site they think would be ideal for this particular experiment. There's a metal frame you can see on the right side of the screen. They use that to determine the size of what this box will be on the seafloor. Once they pick a site, they will either collect specimens from within that site, or in this case, I believe we left some specimens inside the box, and they will prepare the site, take samples from the area. We'll come back the next day. The pilots will put down an adhesive caulking on the seafloor. And then they'll set the first box down. It's a mesh box. You can see that in the background there. Everything has to be precise. So the scientists are constantly referencing photos from the previous day, screenshots, checking out all the cameras because they have a very, very specific idea of where they want these boxes to sit. And then once the mesh box is set down on top, then the pilots have the tricky task of lowering this covering box on top of that. So they have to line up the angles, set the box down on there, press everything down so it seals to the seafloor, and then the process of pumping dye begins. That takes about 30-35 minutes. After that, the period we're now is where we wait for about 3 hours for that dye to stain everything in there. Then we'll pump the dye back out. Then the pilots can remove that outer box, stow it safely on Sebastian, and then if we have time we'll do some more perhaps sampling or exploration. I haven't seen what the rest of the dive will look like, but it's a whole day's worth of activities down here. That dye you see that is a very vivid crimson is non-toxic. It's been tested by the scientists. It does exactly what they want, but it's not harmful to the area. And Dr. Monica Bright's going to show off her camera skills here for us. But before that, we're going to calibrate the camera joystick. How's your day going, Alex?
Good. Yours?
My day's going great.
You guys, we all went to the thing, Russ and Chris.
Yeah, that's right. Well, that's okay.
Yeah. That'll be good.
Is there anything specific you're looking for, Monica?
I'm just checking out the area, maybe we see some nice animals, you know.
Yeah, excellent.
This staining box is working with stains, and we can take our time to just slowly move around.
Yeah.
It's a very nice area, I like a lot because the flow of the subsurface fluid, it comes out really at defined cracks, and you see this when you see these lines, you know, some are more active than others, and if you have this active, more, you know, a little bit higher temperature hydrogen sulfide, then you see these mixes between mussels and tube worms, like, and this is, it's quite simple to interpret because in between are those really, you know, basalt without cracks where nothing can come out. So basically on the broken parts fluid can emerge. So this is the disadvantage is that we will try to break these rocks exactly at the crack when we recover it, or to get it out, and this will be a big challenge because it's more than, for sure, more than 10 centimeters, and the plates basically you can see very large and very heavy.
Yeah.
So, but when you look closer here, you see all kinds of limpets on the mussels, but very often they're also on the tube worms, and you see smaller tube worms growing on the larger tube worms. That happens usually. difficulty is that the really small tube worms are difficult to see because then everything is white in white now because the plume is so tiny. So yeah, this is why I developed also some plastic cubes you can take apart, and one of them we deployed right in the mesh box. They have the size of a petri dish, and we drilled about 300 grooves in it on these plates, and then we put the plates together into a cube. So when they come up, I can just take apart the cube into plates and look under the dissecting microscope for small, really, really small larvae. So this is, and actually it worked also. This is what we did then for years. So to basically collect them.
That's awesome. So if you weren't here earlier this morning, inside the box there is a cube with essentially layers of petri dish sized plastic that they're hoping larvae will enter so that they can examine those easily once we get back to the surface.
Okay. Der ist gerade. Den habe ich lesen gesehen.
Ja?
Mhm.
Okay. Then probably go up there.
Yeah. I was just moving around a little bit here.
How long do tube worms live, Monica?
How long?
Yeah.
Yeah, this is a good question. A very good question. So they're probably not very long-lived because such individual clumps can come and go fast. We know that they can grow almost a meter in the first year of their life, but then they taper off now because otherwise you might find tube worms 3 meters long, and that we don't find now. But after the last volcanic eruption, we Sabine and me, we followed several vent sites or individual clumps that were very small first, and then we also threw some colonization devices in it. But basically we took pictures for the consecutive 3 years. We were there 3 times, or 1, 2, 3, 4 times, several times we were there. And in doing this, we saw that some of the clumps were basically there 1 year, and when we came back a year later, they were gone. So they were all dead.
Wow.
But they were there. And others were there 2 years, and after 2 years they were dead. And then we had also some that were there after 4 years. And after that, we didn't follow it anymore. So, because the funding was over for this project.
Yeah.
But that means that what you see large here and you think it's very permanent or so, is reality is that it can look great today and it can be gone very fast a few days or a few weeks later or months later. Because if the vent flow ceases, that the tube worms cannot survive long with it because the symbiont have no chemicals anymore for chemosynthesis, so they cannot nourish the host anymore. And I don't know how long they can starve, but probably not so long.
Yeah.
So individual large areas can stay very long. Like we know vent sites in this area, they have the name. They got the name before even basically they got the name before the last volcanic eruptions or even before the one previous one, because in '92 there was also an eruption and people started to study it. And the same places basically that got paved over with new lava, they appeared pretty much in the same place again after the eruption. And
Okay.
some were gone and never came back. So also this is very dynamic.
Yeah. So the tube worms are reliant on their symbiont, the bacteria. The bacteria are reliant on getting good fluid flow.
Right.
We hope no volcanoes erupt and wipe out. So it's a very fragile organism. They rely on a lot of things that are outside of their control then, right?
Yeah, yeah. I mean, you can see this also. The symbionts are sulfur bacteria, and they take the hydrogen sulfide and can make as intermediate elemental sulfur. And therefore, the trophosome, so the organ where the seeding goes lighter and lighter, no? But we measure this also, the concentration of sulfur, so their storage. But we know also, and they always look kind of healthy to us, no? But we know also if at this place sulfur sulfide emission stops, then they have only several hours, and then the trophosome basically goes black, and they used it up all, no? So, and the next moment, sulfide could come back in this environment, you know, and then it changes the color again. So, the uptake of hydrogen sulfide, also oxygen, is super high.
Okay.
Carbon fixation rates are very, very high in this animal.
Wow.
So, by the bacteria.
That's crazy. And so when the plumes are out, the two rooms themselves aren't feeding, but is that so the bacteria can have access to the fluid?
Yeah, because the tube worms don't have a mouth anymore, so they have no digestive system at all. They reduce it when they are very small. And the plume basically is like, you can picture it's like the gill of a fish, no? It picks up not only oxygen, but also hydrogen sulfide and nitrate, and then CO2 goes in with diffusion, but everything they need is coming from there. And then they have this blood vascular system that transports all the chemicals to the symbionts.
Okay.
And you can measure this also because there's two large blood vessels in the body. One is like at the original area of the stomach, no, huge, and the other one is at the back. And if you would measure basically the chemical concentration in the blood that is fresh coming from the outside, basically going into the animal or to the bacteria, there's a very different concentration on chemicals than the one that goes up again, basically to get replenished.
Oh, okay.
Yeah. This looks good. Right. Okay, I'll let you move around a little bit. Sabine is taking over and shows you something about other animals except tube worms, because there are many that are interesting.
So we have Dr. Sabina Gollner coming on. She's gonna explore the seafloor with us a little bit. So Sabina's on the scientist microphone. She's operating the camera, looking for some cool stuff. Then we have Zach's pilot, Alex is co-pilot, and I'm Tyler on the other microphone.
So yeah, thanks, Pat. So there are also like many other animals living at hydrothermal vents. Here in the center you can see, for example, a polychaete, a bristle worm that is now sitting right on one of the Patmodilus mussels. And so we studied also the associated fauna animals since a long time already here. And in a community like that we see right now, like more mature communities, we find typically about 50 to 60 species associated to the tube worms and mussels. And very abundant are the polychaetes, as you can see here, but also we have all kinds of different limpets. We can also zoom in here. The limpets, probably the ones who are viewing also right now, you know, also from the tidal areas, so from rocky substrate. Of course, here we have different species. This is how far I can zoom in. But you can basically see that these limpets use all areas that they can. So they also, like, for example, settle on the mussel shells, but also on the tube-on tubes, on the rock. So you can see different species. The yellow one is Lepidodrillus, and the whitish one, a little bit to a lower part, would be Olepidopsis. And what else do we have here? A little bit in the back. Yeah, I can probably have to go for another place because I cannot really zoom in further. But in the back there's also another polychaete sitting, Pa alvinella, that is sticking out of a small tube. But I think it's not really so well visible, so I will zoom out a bit and look probably for a spot that is a bit closer by. Ah yeah, here we go. So basically you can see other worms that are hiding actually behind the rift that's currently, where you can currently see the plume. This is Par alvinella. So you can see one on top of the rifter tube and one actually below the lowest muscle that we can see here in this view. Again, limpets, but also, there are also snails here, like on the muscle that's now in the center. With again limpets sitting on, but also the more like whitish shiny is like a snail. That's also very common here. And again, the polychaetes that we also just have seen on in the other view. So basically all the small animals, they really like to basically crawl and live between the muscles and the tubes. You can also see the byssus threads of the muscle and they really like this interstitial spaces. So this would be the macrofauna, so basically all animals that are larger than 1 millimeter in size. But then we also have a lot of different species that are even smaller than that, the myofauna. And here we mainly find, for example, copepods and nematodes, so small worms, small crustaceans. And they're actually probably one of the most extreme animals because the larger animals, like the mussel, for example, can close its shell to protect itself from the vent fluids. But like the smaller animals, they're directly exposed to it. And for example, one of the animals that we also study here on this expedition, a copepod family called Direvultidae. When you look at them under the microscope, they're a bit smaller than 1 millimeter in size. They're bright red, so they also have a lot of hemoglobin. They also have a special blood that has a very high oxygen affinity, so they can basically grab all the oxygen that they can take from the surrounding water, which allows them to live like in very low oxygen environments.
Two of those polychaetes are relatively.
Yes, yeah.
See them?
Mm-hmm. Right on top of the, yeah, can go in one direction. Here we go. Yeah, yeah.
So why, we were at events in the Atlantic earlier this year.
Mhm.
Every single event that we went to was teeming with shrimp.
Yes.
You couldn't find one without shrimp. In fact, sometimes you could tell you were getting near one of the events because you'd see shrimp in the water.
Mm-hmm.
But here, there seems like there's none. Do you know why is that? Or?
So when we look at hydrothermal vents, like globally, we have several biogeographic provinces, we call that. So basically, we find a completely different set of species in the Atlantic than, for example, in the Pacific. So like one of these provinces would be like on the Mid-Atlantic Ridge. If we would go to hydrothermal vents that are in the Indian Ocean, you would again find different species. And that also has to do with plate tectonics and how the ocean basically evolves and where are the barriers for dispersal.
So it's more geographic than a different kind of vent. Like if those shrimp were here, they could thrive here. It's just they're not.
It has to do with biogeography, and but in addition to like the large biogeographic regions that we have, what's also very fascinating is that every vent field that we visit is also a bit different. And this has to do with different depths, but also with the different vent fluids, so different temperatures, different chemicals that we find in where the animals are adapted to. That's also what makes this ecosystem so unique, because basically everywhere we look, it's different communities, and really adapted to this to the conditions that are found there.
Is polychaete a predator? Is he looking around for prey?
Yeah, for this species, I don't know, but typically polychaetes either they predate or they are detritus feeders, so basically ingest whatever is there and get the most out of it. But for this species, I don't know if it's a predator or not. And also for many species, it's very difficult to find out. For this, you would typically do, for example, isotope studies, and this you can tell in what level of food chain there are, or you can also look at their mouth parts. It also helps in some cases to find out what they're eating. But all these things are rather difficult to study in the deep sea because, But like here in the back, we'd have the polychaetes that are in the white worms, the stabilites in the back here. Let's see if you can get it sharp. Not really, but these would be filtering the water. The ones in the back, the small ones.
Oh, look at that crab there.
Mm-hmm. But you also see that these species are all basically adapted to a certain temperature and chemical regimes. So the tube worms live basically at higher temperatures than the mussels. The sabellids, the white worms that you see, they are exposed to lower temperatures, and also the anemones that you can see here. So I'll try to zoom in. They also live at the lower stress gradient. Now they don't have their tentacles out, but you can see here the two anemones. 3, also a very small one. Next to it here. Another one.
Oh, yeah.
Mhm. But like compared to other deep sea ecosystems, like when we look, for example, at the deep sea sediments, the amount of species that we find here is rather low because the animals have to adapt to these extreme conditions. So here we have very unique species, but low diversity and high biomass. You can see like the tube worms that it's like really high biomass. And when we look, for example, on deep superficial plains in the sediments, we find many more species, but like in with lower biomasses, much lower biomasses. This has to do basically with the energy that's provided by the vent fluids that the microbes can use to produce biomass.
It's a very small area of habitable space down here, so everyone crowds in.
Yes,
all the way.
yeah.
Yeah.
So basically, the deep sea is typically rather poor in food, and this is basically an oasis for them. So whoever can manage to get there and can endure like these extreme conditions is in heaven.
Yeah.
Kind of.
Heaven on the
Unless you get
seafloor.
the vent fluid, gets too hot or there's a volcanic eruption.
Do the mussels and tube worms help each other in any way, or are they just there totally separate, no interaction whatsoever?
Yeah, so they both. So typically the tube worms settle at places with a bit higher temperatures, and when there's also part of the successional stages when the vent fluids get a bit less, the mussels basically invade the environment.
Gotcha.
Yeah.
Okay. So will they prevent tube worms from growing there if too many of them come in?
Typically the tube worms are first there.
Okay, so they'll establish their territory.
Yeah.
Okay. Got a nice shot of the shimmer that identifies hydrothermal vent fluid.
I won't see you for a bit after that. Maybe in the one in December after that. Yeah, on that one. Which is, the beach is continuous. It's
I'm off next month, and then I come back mid-September. And then I'm off for next one.
Next year. Oh, next year, come back. No, December. Oh, you do, are you?
December 1.
And then we have signed up for the first one. Before then.
But they're all on trip.
Yeah.
So if you're joining us, there's a live images from the seafloor on the East Pacific Rise for the Underworld of Hydrothermal Events expedition. These images are coming to you live from ROV Sebastian, a remotely operated vehicle that is currently 2.5 kilometers away from the ship, down on the seafloor. And we are exploring some hydrothermal vent sites. So we have a long experiment that we're deploying today, so we got a bit of a pause here to explore the seafloor. Currently we're waiting for some dye that the scientists deployed to stain a specific site they've selected, and that process takes about 3 hours. So right now we're getting some good views of what's happening down here on the bottom of the Pacific Ocean. So Zach, you've seen quite a few hydrothermal vent fields, right?
Sorry?
There's a
I've definitely
Yeah.
seen other ones. I don't know if I'd say quite a few. I think that depends on your qualifiers. But why is that?
just wondering if how this looks to you compared to other ones. What are some undersea scenes you've seen in hydrothermal vents? Have you seen black smokers?
Oh yeah, yeah. It's just very different in terms of the ones we went to last time. Were much less diffuse, you know. So you would have a large area of nothing, and then desert-like, and then you see all the life starting to appear, and then you run into this giant, huge cathedral-like vent full and teeming with life, you know, and then, but then nothing was around it, you know, until you get to the next vent. As opposed to here, it's more like a giant forest of these worms, you know. So they're both really cool, just totally different, you know.
Yeah.
You know, do they have like the big smokers here too? Huh?
Yes, there are also black smokers
We
here.
just haven't really
Yeah.
gone to them
Yeah.
yet, no? Yeah, that would be cool to see too.
It's also like a bit further north of where we are currently, and we plan also to go there during this expedition.
Do the Riftia colonize those as well, or they prefer the more diffuse?
No, the Rifties, they prefer diffuse flow, so around, let's say, 20 degrees Celsius, roughly, a bit less, but like 10 to 20 degrees Celsius. And of course, the black smokers, they have very hot water.
Yeah.
Can be more than 3 degrees Celsius, and directly at the black smoker, where like the smoke is coming out the hot water, there's no life, because of course no animal life that can live there. But at the base of the black smokers, we find the Alvinella pompeiana worm, which lives also in like white tubes made out of chitin. And this is probably the hottest animal on Earth, because it's also like really sitting on the black smoker and really like exposed to really hot temperatures. And they also made like measurements, like what temperatures are measured around these Pompeii worms, and really like next to the tube it can be more than 100 degrees Celsius. But by building the tube and by being mobile, the animal itself exposes itself about to 40 degrees Celsius max. So it's really a tricky way to also like live in such an extreme environment.
I remember we'd see the Rimicaris in the Atlantic flying in and out.
Yes.
And sometimes you would see one that got a little too crazy, he would be burnt, you know.
Yeah,
like,
yeah. Also, like here in 2000, I was here also in 2006, 7, and 9, and we also deployed this colonization substrate, this sponges basically, also on one of the black smokers with this Alvinella pompeiana. And one of the ones that we recovered, we deployed 4 sponges, and 3.5 of them were burned away.
wow.
In the time that, so you also see that the habitat is very dynamic, and also the fluids can change, and So that was also an interesting experience to get a burned, experiment back. It was at Bio 9 site. So here at Bio 9 we have also black smokers. And what is also interesting, so we had this volcanic eruption here in 2005 and 6, which basically filled up the ACT with lava that also then flew over. But a few places remained because they were higher up. So, for example, including one of these black smokers that was just higher than the lava flow could go. And also at the eastward side where we've been on the first day, also there the lava couldn't reach. And actually the communities that could survive there, they were important for the recolonization afterwards.
It's this little island of life after the volcano eruption then, huh?
Yeah.
The only thing I remember was the song. Everything else is a blur. Yeah. Where's the training at?
Hey, how does it go when you're coming and leaving the boat?
Go on leave.
But I mean, like, how it was at my old job is if you step foot on the boat that day, either coming or going, that's a work day. That's not travel. Is that how it is here?
Tony, clarify.
Hi there, everyone. In the inset, you can see the bathymetry of the area that we're working in here. It was collected by AUV Sentry on a previous expedition, but it can just give you an idea. It is at 2.5 times exaggeration, so it's not as extreme as it's depicted here. And obviously, Sebastian is not to scale. but it'd be a little bit tricky to find the submarine on this screen if it wasn't a little bit larger than it actually is. But just to give you a sense of the bathymetry that's in this area, down along this channel. And how much it stands out amongst against the rest of the background here on the seafloor.
Cute, no?
Mhm.
Sorry?
Could tell the story of the babies.
Yeah, very like So they're big, also because the sperm type of the sparkles. They're all actually sometimes, so that's the reason why they're on acid. It's crazy. Decide where to put the dirt. No.
To go today upwards to Teddy Bear and check out the other thing.
All right, everyone. Being that it's the top of the hour, we can give our hourly station ID. You're watching footage from ROV Sebastian, down 2,500 meters below the sea surface in the East Pacific Rise, just off of Mexico and Central America. We were aboard research vessel Falcor of the Schmidt Ocean Institute, and if you're just joining us, in the top right corner you can see there's a mesh box that's encased in another box that we've pumped red dye into. So that's just non-toxic dye, nothing to worry about in there. And the purpose of that is to dye the organisms that are within the small quadrant, and we will be letting that sit for a few hours. So stay with us for some nice soothing imagery of the seafloor and these hydrothermal vents. But we do have to sit around and kind of maintain a presence to make sure that the dye sets in as expected. And the box that we're focused on now is one that we put down 2 days ago that has entered into that closed area. Then we know that it has come up through the seafloor. So there are different vents and areas that organisms can make their way in. And if they are not dyed, then we know that they are novel organisms that have gotten in there. And you can see all of the other fauna that are on this floor, the seafloor here, that certainly there's quite a bit of opportunity for things to make their way in there.
1 hour we start pumping back the dye.
So how did you guys got into the ROV business? One of our scientists here, Andre, has just asked, how'd you guys get into the ROV business? Zach Bright, our ROV supervisor, who's the pilot and controlling the camera right now. You want to share your story, Zach?
All right, I don't know that it's that interesting, but
Right into that mic over on your left-hand side there.
I was going to school for chemistry, and I quite enjoyed it, but it was a part of my life where it was getting a little tedious, and I had a friend who had just got out of the Navy, and he was working on underwater robots, and I thought, well, that sounds really interesting and crazy. I think I'll try it for a year, and that was 2005, so still doing it, obviously, and that's about it, really. Not that crazy. What about you, Alex?
Alex Paris, one of our other, he's currently co-pilot. Alex Paris, how'd you get into the biz?
I was going to school for engineering, ended up getting an internship, and then working for Schilling Robotics, who are the manufacturers of the robotic arms we have here on Sebastian. Worked there as an engineer and an offshore engineer for about 10 years total, and then the opportunity to do this came along and I couldn't pass it up.
Right.
Is there like a training, like a special school you can follow to become a ROV pilot or not? So I guess like sometimes in industry, but typically you learn by doing, or?
Typically you learn by doing. They do have ROV schools, but at least back when I was getting into it, it's more just that they get you in the door kind of thing, you know? What about you, Fulmer?
Well, I'm not an RV pilot.
How'd you get all this?
Yeah, well, I did an undergrad at Dalhousie and Dalhousie University in Halifax, Nova Scotia, in a completely unrelated field. And then I worked on some sailing boats for a while to pay off student loans, and then realized that I wanted something more and went back to school and did marine geomatics. Worked in some laboratories back in Halifax, doing some ocean technology development, working with a lot of industry partners and collaborative research agreements, mostly in habitat suitability mapping using backscatter and bathymetry, a lot of multi-beam stuff, drop cameras, ground truthing, and then my best friend and my oldest friend, who I've known since I was 3 years old, was a second officer on board Falcor, and he told me about an opening. And then a few years later, now I'm the lead technician. So, not exactly nepotism, but got my foot in the door through a friend.
Who was that?
Ty McManus.
So he's not here anymore.
No, he's now the captain of Legend, which is an expedition yacht, and they're currently working out of the Mediterranean. They do some Arctic expeditions. Well, they were up in Svalbard, and then they were down in Antarctica last Arctic summer, or Antarctic summer. But yeah. And look who just entered the room. It isn't Tomer. Tomer Ketter, do you want to give us your story about how you got into this industry?
Now, what's your origin story?
Yeah.
No, I'm joking. And I ended my trail in a marina, and I was sitting there looking at all the boats going in and out, and I thought that has to be the best way to explore, and it was, still is. So I went into ocean science degree program, 3-year program. That was really great, and I got a lot of hands-on experience, sailing, diving, working on research vessels. And after that, I worked as a diver for a couple of years. And after that, I went back into grad school and I got a degree in marine geoscience and specialized in mapping the ocean floor. And then I started doing a lot of hydrographic work, ocean mapping stuff for different institutions, mostly in research. And now I'm with Schmidt.
And you also commissioned the Bat Galim.
I also commissioned the Bat Galim, which is the Israeli research vessel. It's equivalent to a regional class UNOS. And it has the full acoustic and network suite that all the other vessels have. It was a really challenging project to put everything together from the bottom up, but very educating as well. And then I worked for a few years for Seabed 2030 and for the Multi-Beam Advisory Committee and for an X-Prize team that won the Ocean Discovery Challenge and a bunch of other things. I started a nonprofit. It's called Map the Gaps, and it's dedicated to mapping the ocean floor for conservation and science in different parts of the world.
How much do we know about the ocean floor?
So right now, statistics are around 25%
Known,
mapped,
mapped.
but that also varies a lot. What does it mean actually that's mapped? It changes. So at every depth, there's a different resolution that we're looking at. And these depths are talking about one sounding every 400 meters, which is not amazing, but that's the standard that they set. It's definitely much better than the satellite gravity models that we have that you can all see in places like Google Earth. Sorry.
Pull up some Google Earth imagery for everyone.
Oh yeah.
If you want to hit the first one.
Yeah, John's going to show us. Oh, there you go. So, do you want to zoom in? Oh, that one. Right. You can zoom in and show us the difference between a gravity-based model and a multi-beam. The difference in detail that we get.
You're somewhere that's Google Earth that's open source or free, available for anyone to look at. You can see the region that we're in, all of the high resolution multi-beam that we showed in kind of previously, of how detailed this is. And then you can see if we just scroll over and then it suddenly gets blurry. I'm going to describe what we're seeing here, Tom.
Yeah, it looks kind of out of focus, but it's just a very low resolution model that is the best technology that we have available. Basically, it's from satellites that measure the gravity in orbit to a very fine resolution, and from the changes in gravity over different points on the surface of a planet, we can model, kind of reverse engineer the surface of the Earth. And right now we're looking at some seamounts. One of them, that one, is mapped to a good resolution with a multi-beam. And the other ones, more to the top left right there, you can see are kind of modeled. They have this conical shape that is statistically generated. So they're not actual measurements of the seafloor. It's more like a prediction. But in the areas that we did map with the multi-beam, it's good enough that we could kind of speculate or make an assumption about the processes that shape the seafloor in that region. Now John is looking on the map. He's looking at Hawaii. That's a big island.
as we call it, the previous vessel. And we had a lot of collaborations with people from that institute, from the university, and they had their own research vessels, one of which, the Moana, has done extensive mapping in this area, so you can see how well mapped the area surrounding Hawaii is. What a great job they've done in a massive undertaking of mapping these areas. If you consider the scale of it, you can't see the scale that we're looking at here. Where is it? Where's the scale bar? It's not showing. I'll have to add that back in. I was trying to do it for pretty looks, for aesthetics earlier, but. And then if you map elsewhere, where we previously were on the first expedition of Falcor 2 in the mid-Atlantic ridge, the same kind of thing. You can see these almost like train tracks or track lines of any vessels with multi-beam systems that have passed through these areas, and with as much collaboration with groups like Tomer was working with previously, the JEPCO 2030, trying just to collaborate and reduce duplicated effort and make sure that all the vessels that are outfitted with the sonar systems that are capable of producing this data, if we all work together to try and not map the same areas, because traditionally the easiest routes to get from point A to point B, you'll have a lot of ships traveling the same route. They're given the Great Circle from main ports of interest, or just different weather patterns of taking the trades across the Atlantic. But you can see here that there are some gaps, hence Tomer's nonprofit, Map the Gaps. So in an effort to kind of fill that in, it's really a collective effort from people all over the world of international groups. So it's kind of beautiful that the ocean being the final frontier of Earth exploration. We're a little too early to be exploring our solar system, but a little too late to be finding new continents. But we're right in the sweet spot to be exploring the ocean.
Yep, now's the time to get into it.
Yeah. Oh, shout out to Nova Scotia here.
Some of our best crew members are from Nova Scotia,
right?
but also some of the worst.
And boom, right back here to the East Pacific Rise.
Yeah. And you can actually see from an area that's been mapped with the multi-beam, you can actually put together an idea of what the processes that are shaping the seafloor, what kind of seafloor that is. And you can't do that with satellite bathymetry.
Yeah, and there's a really cool part about the satellite altimetry data, which is like the modeled stuff that Tomer was talking about. Just all of the satellites that pass over, like Tomer was saying, the gravitational effect that it has on the sea surface with thousands and thousands of passes over these areas, and they collect the data of how high the satellite is from the sea surface. When they collect enough of that, then the water mass actually gathers around the higher areas of gravitational force of these large rock formations that make up seamounts. And a seamount being a mountain under the sea and is technically classified as anything over 1,000 meters.
Right.
So these are big.
1,000 meters of prominence.
Yes.
That means relative to the seafloor around it. And there's recently a publication that identified something like 20,000 new seamounts that are unknown.
And if we're transiting through an area, because Falcor 2 and the Schmidt Ocean Institute, we work internationally, we spent a whole lot of time in the Pacific, but as we came over from Spain after the refit in Galicia and Vigo, we passed the Atlantic and then we were set up in Puerto Rico. So the different areas that we go to when we do pass through a new unmapped region, If we're not constrained by time or schedule, then we can check out the satellite altimetry data and we can say, oh, it's likely that there's going to be a seamount here. And actually on our way out here, maybe Tomer, if you want to talk about that, because I was in bed when this happened, and Tomer was on watch when we mapped a brand new seamount.
Right. We happened to pass just above a fairly large feature. It was about 1,600 meters high. It was about a mile of prominence compared to the 4,000 meter seafloor around it, and it was about 2,000 meters, or sorry, like 4,000 meters wide, and it was a perfect round kind of cone without the top. So it was a flat head seamount, like an extinct volcano. So that was really exciting to discover. And after that, we noticed a few more of those, a little smaller, but there were, I think, 6 or 7 other ones after that. So almost anywhere you'll go, you're going to find something that no one's ever seen, no one even knew about.
And it really is remarkable how the satellite altimetry data has made it incredibly easy. Well, for us who have these super advanced acoustic sonar multi-beam systems on our ship, and when we're passing through, we can kind of just go off course a little bit, make one pass over it, and then if we do have time, we can go back and map the summit of the seamount in finer detail with our different systems. But Tomer, do you want to explain what sonar systems we have on board Falcor 2?
Ooh, Falcor has a bunch of sonars. So for mapping the seafloor, we have 3 different ones. The biggest one is called the EM124, and it can map the deepest places in the ocean. So it's rated, it can reach 11 kilometers almost, which is where the bottom of the Mariana Trench is, Challenger Deep. And the next sonar we have is EM 712. It's a bit smaller, uses a higher frequency, and that one is ideal for anything from 2,000 meters deep up to 100. I have a shallow water multi-beam on this boat. It's called the EM 2040. It's a very high frequency, and it can generate very high resolution maps up to about 200 meters. And we have some more sonars that are used to map in other ways. For example, we have a sub-bottom profiler that, when it's kind of fine-tuned to the right settings, it generates a really nice cross-section of the substructure. Those are the layers of sediment and rock that make up the seafloor. It can penetrate several hundred meters below the seafloor. For example, the depth of 4,000 meters. So that's really exciting to look at too sometimes. Gives us a really good idea about the age of the seafloor, and again, a deeper look into the processes that are happening in that place. We also have some sonars that map the water column above the seafloor. They're called ADCPs, and they can give us a really good idea of the currents in real time at various kind of depth layers in the ocean. John, can we show it? Or...
Yeah, you can put that over there.
Oh, if you want that.
I'll have to shift some screens around and stuff. Yeah, so as Tomer mentioned, the acoustic Doppler current profilers, the ADCPs, so they measure the velocity of the water current at different depths or bins. And that's, sorry, we've got to shuffle some things around here. may have to come back to that one if we don't have that set to go in. So in commissioning the new vessel, Falcor 2, and getting everything up and running, for the live streaming, we have a new setup for doing production and streaming or broadcasting the dives. So we have the MMTs of the very well-spoken, soothing voice of Alex Havens, our multimedia technician. That is a new position on the vehicle, or on the vessel, that we did not have on Falcor Classic. So previously we were kind of, the marine technicians on board were trying to do double duty of maintaining all the systems and operating everything, maintenance, upkeep, repair, and then also doing the streaming. So we're very lucky to have Alex Havens, and then Sophia is his alternate, and she will be back out for our next cruise. And they are really taking it to the next level, and they have the time and the knowledge to really dive in. So as we're filling in for Alex as he's taking a little bit of a break, I'm trying to navigate his stream deck here, and let's see if I can find my way around here. I'm a little rusty, so bear with us here. But the current profilers will give are very useful for when we're launching the ROV, so we can get everything set up and we can call out to the pilots and the bridge to let them know where the current is going to be, if they're going to be launching and pulled away from the vessel or back in toward the vessel. And that way the bridge can kind of set up the ship so that we can just drift while the ROV goes down and gets out of these stratified currents on its descent down to the seafloor, and then we can set up on location and make sure that Sebastian gets to exactly where the visiting science party would like us to go. And that's another interesting system that we have, our USBL, or ultra short baseline. So that's our acoustic positioning. So we have a transceiver head that is on a pole that extends down out of the hull of the ship. So we lower that down before we deploy Sebastian. And there are beacons on Sebastian. So we send out an acoustic pulse from the transceiver head. It travels through the water column, reaches the beacon that's on the vessel, or on the vehicle rather, and then that responds back to the transceiver head, and using our rho theta calculation, so the angle and the distance, we can calculate to fairly high accuracies of the absolute position of Sebastian. So we've been taking waypoints when we go down here. We have logging software. We use C-Log on board here that the Schmidt Ocean Institute has been funding the development of and keeping it completely open source, as is the mandate of the Schmidt Ocean Institute. That's what our founders really had in mind when they launched Schmidt Ocean Institute, and to be able to have the funding and investment into these new ocean technologies and have it available to everyone, and make it as ubiquitous and far-reaching as possible. And hence the efforts for the outreach, of which many other institutes are doing as well. And it's just wonderful to see everyone working together and kind of sharing ideas and resources and data sets. So the multi-beam that we have that you saw earlier, which I can pull up quickly. I know how to do that much. We can bring this stuff back up here. So we were given this multi-beam data, which is a massive help, because with the resolution that we're collecting for, just one moment, stand by. So this multi-beam data that we've collected, or that was previously collected, Monica Bright, the chief scientist on this expedition, her and her team were able to plan out the areas that they wanted to return to. And if you've been following along for the last couple of days, you've probably seen markers from other expeditions or drop weights from landers. So this area was previously mapped, and we can leave a waypoint of where we want to go back to, such as the... Zach, do you want to zoom out and show the box from the other day that we deployed? So the box that we're waiting with the dye here, we've mentioned a few times, but for anyone who's just joining us, the box in the back there is one we deployed 2 days ago. So we had the waypoint, we dropped the ROV in, we go down, and by using the acoustic positioning from the USBL system, we kind of land right on the money, and we're right back where we want to be. And that's it's a fairly complex chain of events that allow that to happen. It's the GNSS system that we have, or the Global Navigation Satellite System, which is GPS, Beidou, and oh gosh, I'm blanking on the other constellations used. GLONASS. So GLONASS, Beidou, and GPS are all satellite systems that we use for the positioning, much in the same way that you'd be able to use Google Maps or something else to find directions to your favorite restaurant. We can use that to get to locations and position the vessel, and then down through the water column we use the USBL, but because the ship is moving around and rolling and pitching and heaving on the sea surface, we have motion reference units or inertial motion units, depending on which company is developing them. So we have multiple redundant systems in case one goes down, and then also for the validation of the positions that we're getting from the independent systems. And so we have the ship's absolute position in on the globe, and then through the acoustic positioning, if we move, the motion reference unit can calculate which position the vessel was in, Falcor 2 was in, when it emitted the acoustic trigger. And then when it comes back, if we're rolled over to the opposite direction, when it receives it, it can calculate that, and it still knows the position that the beacon is in. So we have 2 beacons on Falcor right now. One is in responder mode, the other one is transponder mode. So down through the umbilical, through the fiber optics, we can send a trigger, and that will have the beacon send off an acoustic signal that we receive. And then we can also use the backup one to interrogate it with the transceiver head. Transceiver standing for transmit and receive. And then that's how we know where we are. And with the mission planning, I mean, it's obviously a lot goes into planning these expeditions, but just the planning that the team has done here just makes life so much easier, that they have waypoints, they have dive plans, they know what they're going to be putting on the vessel or on the vehicle 2 days ahead. So we have a 5-member team of the ROV pilot outfit right now. So doing an extended 12 dives, so early in the morning, and then after we come on deck, some of the ROV pilots and technicians will be offloading some of the gear or putting new gear on. We have a mass spectrometer, which is being worked on in the robotics lab at the moment, and that's being prepared to be loaded onto the vessel to go down and use in 2 days' time, I believe. But obviously these dye boxes and the mesh boxes take up quite a bit of space on the porch. I can actually cut over to here. You can see, let's go back to this one. The situation camera is a much more static camera than the science cam, the 4K camera. You're all watching this in 1080, but so the sit cam is in 1080, but obviously it's a lot less pretty than the 4K science camera that we use for actual species identification or any other observation footage that we gather. But sorry, Zach, if you pan down a little bit, por favor. So you can see there, that's the porch on the front of the ROV. And the ROV pilots can porch in and porch out to be able to get to other items that we load up on the back, which is kind of underneath the science camera there. And then if, Zach, do you mind moving the science camera around a little bit and people can kind of see? So actually, I'll put a picture-in-picture here for us so we can see what the science camera is actually seeing. So as the image moves around, you can see the camera moving around it fully out.
Oh,
Okay. So there you go. You can see that we have control. And then down beneath where the camera was, we have bio boxes 1 and 2. So those are have had a little bit of work done the last couple of days to make them seal better so that when the samples come up, because you can see on screen now it's 1.94 degrees Celsius down here, which is 2 degrees above freezing. And when we come up through the water column, all sorts of different things are happening through the water. We're seeing an oxygen minimum zone. You see the thermocline, where the temperature kind of stays constant, and then the halocline, where the salt content or the salinity, you can see we're at 34.6 practical salinity units down at this depth. So we have a CTD on the vehicle. We have a dissolved oxygen sensor on the vehicle. We have multiple strain gauges or depth sensors that we use to compare against one another. And all of that data comes up. We collect it in our acquisition system. We're using RV-DAS and Influx database to collect all of the data, and then we can do calculations on that and with transforms so that we can calculate the true oxygen saturation. And then, ooh, there you go. That's a nice one. Sorry, I'll go full screen for that. Sorry about that, everyone. There you go. Somebody's going for a swim. But all of the data that we collect on the vessel and on the vehicle, including the samples, the findings, the data sets, and the video, or the vision as some people refer to it as, is all made available to the public after an agreed upon time. Obviously, the work and study that the researchers that join us on RV Falcor 2, they get a bit of a head start to be able to publish their papers on their findings, but ultimately it is shared, completely open source. And the founders have also committed to investing money in making the data available if it's been published in a scientific journal. If it's required to pay for a subscription to get that data, then the founders will pay for that to make that open source as well. So it really is quite an incredible commitment that they've made to ensure a catalyst to kind of propel ocean science as quickly as possible, instead of waiting around for different governments to kind of get the funding together and get organized. They're trying to do their part, and it's I would say it's inspired quite a bunch of other groups to do the same. We're not the first, but hopefully we can contribute more to the scientific community and just make all of this available for everyone. And the outreach component of this is wonderful, and something that is very important to the founders, that we kind of instill some excitement in younger generations, or anyone who's just sitting at home watching this, of citizen science and contribution. And then just making sure that people understand that it's not just mud at the bottom of the ocean, and that there's so much more life that's throughout the water column as well. So when we come back up at the end of this dive, there's a whole lot that'll be going on behind the scenes. So unfortunately, I doubt we'll have any narration going on. But if there are any cool features while we're on our ascent, not features, but any pelagic organisms or anything, then we'll stop and we'll zoom in on those. And it's very difficult to do, as you can imagine, if you're just free floating in the air and there's something the size of a tennis ball that's a couple meters away, and the pilots will be able to keep the vessel, or keep Sebastian as still as possible to get these great shots and coordinate the lighting and make sure that the thrusters aren't blowing them around. But I guess on that note, Zach, do you want to talk a little bit more about Sebastian? And you can kind of give us the rundown of how you fly it, the different thrusters, how it's powered, hydraulics, etc.
Sure.
I can, let me set your microphone up a little bit better there. So we've still got quite a bit of time to kill until we're ready to pump this guy up. All right, so Zach Bright is our ROV supervisor on board at the moment, and a very skilled pilot, a very skilled technician. He's an all-around great guy. Yeah, he's being modest. So Zach, how do we power Sebastian?
We give it 400 volts. On a lot of boats it'd be 440, but on this boat it's 400. And we step that up into the thousands. And then we send it down at a much lower amperage so that we don't have to have huge wires. And pretty much all long distance ROVs use that sort of a transmission system, like a mini mini distribution network kind of thing. Then when it gets to the bottom, the motor is designed to just accept that higher voltage just straight away. So it doesn't need a transformer on our end. But for running our instrumentation, like 240 and 120 are available. And it just converts it back. And then it goes and powers our cans, which are the computer brains of Sebastian, and process all of the inputs and outputs that we have. And then they also go from the cans to our various junction boxes, and the junction boxes are really just fancy breakout boxes. So we'll have cables from the cans that go to, for example, a light junction box, and then from there it's just spreads out to all the lights and supplies them with the 240 volts as we tell them to come on and off. And we have a Science J box that we are using right now for the mass spec. Obviously not this dive, but this trip we'll be using it, and that one will use it to provide data and power to any kind of equipment the scientists want to use. We also have a core J box. That's the one that goes to all of our sensors and our manips and things like that. A lot of subsea stuff uses just basic serial communications. It's reliable and it's simple, so they still use that. Some of the newer stuff is kind of transitioning to Ethernet or USB type protocols or something, but most all equipment for subsea is still 232 or 485. See, John's looking up at the pump. The pump they brought out here is pretty interesting. Let me turn on a little more light for you here. So this pump, well, that was too much light. But if I go like that.
And, to anyone who thinks that maybe the lens is dirty, that's actually from the Mid-Atlantic Ridge expedition that we did earlier this year. Oh, sorry, my mic is down.
Yeah,
the Mid-Atlantic Ridge expedition that we did, and the vents that were there, they kind of scorched the lens caps. So
yeah, so this is the pump.
They were very hot.
Y'all see us messing with this a lot. This is the pump the scientists brought, and we really like this pump design. It's pretty cool. It comes with its own battery, and it just mounts on the sub, and so it's a system that they can test and don't even need to interface with the sub, and it made it very easy to integrate. It's worked quite well, I think, every time we've tried to use it. So
Yes.
we've been pretty impressed by this whole setup. It's pretty simple. You can see on the top is on off, and on the bottom is just the pump direction. So one way is experiment, then the other way is bag. So that's just going back this way to the very back of the sub where we have a large bag. I don't know if you can put out SD videos on your stream, John, but you could show them the bag if you want. And that's what's pumping the dye. And we're also using that same setup to take water samples of a very large volume. So what is it, 70 liters you guys usually want?
75 liters, and we put in 55 liters to have a bit of room in the bag still left.
Okay.
Because otherwise it would pump up too much, and when you have it, especially like on the surface,
we
don't want to risk that it's
no, you don't want to pop that.
No.
That's you get in trouble for that. So then that power, the motor we talked about, that powers our hydraulics, and the hydraulics are very prevalent in all kinds of subsea equipment because they still, for now, have a better weight to power ratio than magnetic and electric motors and stuff like that. But I think that will change in the future as we develop new materials and things. But for now, like these arms, the Titan 4 arms that we use are amazingly light and strong and just crazy engineering all around, and those are all hydraulic inside. They do have electric signals that go in there just to control the valves and things, but the power behind them is all hydraulic. Same thing with our thrusters. I've been on a sub that had electric thrusters, and you do hear about them now, but most all are still hydraulic.
You can see all the compressor indicators there. You want to maybe talk about some of that?
Yeah, that's for our compensation system. So all of our J boxes, to keep the water out, they're all filled with oil. And you can't just fill them with oil, because then if you were overpressured, you would still get water inside the box. So what we do is we put basically a balloon full of oil with a spring pushing on it, and that's called a compensator. And that will keep those boxes at a certain PSI above ambient. So if you see like this Manips one right here is 5.5 PSI above ambient right now. So as we go down, if there was a hole anywhere in that system, what would happen is the oil would go out instead of water going in. And that would give us an indication both on this gauge, and we have a sensor that's like reading an electronic reading from the volume of that compensator too. And both of those things would tell us long before it got water into the system and damaged it that we have a problem and we need to recover.
And then you can see up in the top right thing there, kind of looks like almost like a shotgun microphone. It's the Seabird Electronics FastCat 49 CTD, which is showing up most of the data that you're seeing on the lower left hand of the screen there. So it's conductivity, temperature, and density. So density translates to depth. So it's using all of those readings to calculate the sound velocity of the water, how fast sound is traveling through this section of water. So as we travel down from the surface to the sea floor, the speed of sound in water changes. It speeds up with the higher conductivity or higher salinity, then the speed of sound is faster. Higher the temperature, the speed of sound is faster, and the higher the density, or the deeper we go, the speed of sound increases as well. So obviously the fluctuations between all three of those variables change quite a bit down through the water column. And when we send a signal of sound out from the acoustic positioning system, the USBL, when we send it out, we measure how long it takes to leave the transceiver head, hit the beacon, and come back. And we know how fast it's traveling because we've recorded the speed of sound with that device on our descent. And so by using the measurement and the other value of the speed, we can then calculate the distance. And then the various small acoustic transducers that are in the USBL, the ultra short baseline, basically means that we have all of these small transducer heads very close to one another, ultra short baseline. And when the phase of the returning signal hits one transducer and then the adjacent transducer, the difference of the phase between those, it can calculate the angle that it came from. And because it's an entire flat head with, I forget how many transducers are in that one. It's the Sonodyne HPT 7000 if anyone wants to check while we're talking about it. But when that comes back, then we can locate where the signal came from. So all of the sensors that are on board, not only does it tell us what the temperature is for scientific data set and collection for this area, it also helps us find out the speed of sound and technically assist us in getting the most accurate positioning possible. Because all of this data, collecting all of this vision or this video and all of the data and samples and everything is wonderful, but if we don't know where it came from, then it's not as helpful as it could be. So it's the integrity of the data and the accuracy is something that we take as seriously as possible, and we've been building towards that, just improving year over year. And we have a data architect on the shore, Karine Bassin, who's done an incredible job of building up a lot of these transforms and takes a lot of our plates of able to monitor the data. And we have certain systems. We have Grafana that displays a lot of the data around the ship, so that we can have things graphed. We can make sure that the readings that we're getting from either our seawater flow-through system, which is taking surface water, we can visualize all of that data, and just at a glance we can see if there's anything that's kind of drifting out of spec. So we have redundant systems up on the surface, and we generally have redundant systems on the submarine. We have many different depth sensors, but at the moment we only have one CTD running. We had some issues with another one that is back going for calibration in the United Kingdom. So we'll have that back for the next trip. Yeah, where did you leave off with the professors? Well, I guess, Sabine, would you like to add anything to that about the planning of the area, why we're here, and...
So are we selected this site, or?
This site, yeah. Go on, move your microphone back.
So the reason why we are at the 90 North area is that we know this
area very, very well. So we've been here a couple of times before, and we actually know the communities very well. So we know all the species that live there, and this actually allows us also to perform this experiment, because we want to basically compare what is living under the surface with what is living on the surface. And to be able to compare this, it helps a lot to already know what is living on the surface. Also, we know the sites very well, so the Tika area, but also further north. We've been here a couple of times, which also helped us to plan the experiment ahead. So we kind of had an idea what we will find. And also, we know the rift tube very well, the communities. And we also know the sequence of eruptions rather well. So every 15 or 20 years, expected there are volcanic eruptions in this area. We also had previous measurements of vent fluids, and most importantly, during the previous expeditions, when we looked actually very carefully on the rocks, we could observe that the babies from the tube bomb actually live like rather deep in the subsurface, so like 10-15 centimeters. And actually, this brought up also the idea of that the dispersal of vent fauna could be via the channels in the subsurface. So this is actually the reason why we are here.
Yeah. Awesome, thank you. And then, do we know what this crab is feeding on right here?
It looks like a dead riftia, or a piece of a riftia. So what you can also see that this crab is often hanging out among the riftia tube bombs, and usually they retract because apparently they don't want to get eaten. But this looks like a dead tube bomb, I would say. And the crab is, yes, it's a plume. It has the plume from the riftia in its right claw, and is currently eating up the riftia. Yeah.
So they don't feed on the riftia when the riftia are living?
I guess they try, but riftia usually like group. They return back to the tube where they are safe. But this one was apparently too slow.
Got caught lacking.
Yeah.
That's awesome. Sorry, Zach, I just noticed there were some questions coming in through the chat. The titanium electric container, the cans, I don't think we can see them from any angles, can we?
No, you could see them if we were streamed on the way up. When we're recovering, you can kind of see them, but we have a lot of big connectors on them, 72 pin connectors, some of them. So there's a lot of stuff going on in that can for sure.
And so, Sabine, where are you working out of? Where do you call home?
Sorry, can you repeat?
Where is your home?
Like where I live?
Where do you live?
I
Yeah,
live in the Netherlands since 10 years, but originally come from Austria. So in 2009, I actually did my PhD, or finished my PhD with Monica, the chief scientist. Afterwards, I went to Germany, lived there for a couple of years, and now since 10 years, I'm in the Netherlands. And since a bit more than 5 years, I'm now employed at the NIOS. It's an Institute for Sea Research in the Netherlands. And I'm very privileged that I'm able to study the deep sea. I've seen many, many nice places.
Also another modest scientist, you're one of the co-PIs.
Yes.
So not just along for the ride.
Yes. And it's also really nice to have this project together with Monica, because of course we have a long history together, we know each other since a long time. And and then we kind of for the last years developed this idea how we could study actually the hypothesis that we have. So it's really nice that all this comes together here on this expedition.
And how many times have you been to this location?
To this location, so my very first expedition was I think in 2003, actually with Stéphane Houdès, who is also here on board. So back then I was a master student and Stéphane was a postdoc. And then again in 2006, 7 and 9. So it's my 5th time here now. But other...
You gotta get you a jacket then, a 5-timer jacket.
Yeah.
Do you get a discount after you go 10 times?
Yeah, good idea.
Unless you haven't been using your punch card then.
Yeah. But I've also studied other vent systems, like for example the Mid-Atlantic Ridge, Rainbow Vent, or my last expedition with a Dutch research vessel was north of Iceland, visiting some shallower vents there.
Yeah.
And But that's basically the place where it all started, also for me in terms of how I got into science.
Was in Iceland or?
No, like here on the East Pacific Rise,
When
back
you were
in
a master's student,
yes, yeah.
And so what did you have a master's thesis on this, or did you write a master's thesis?
Yes, I
on
wrote a
all of this?
master thesis on this and also a PhD thesis on this. So as a master thesis, I studied actually the myofauna, so the small animals that live amongst these tube worms. And then during my PhD, I studied like more communities, so the mussel communities, the tube worms, the Pompeii worms, the bear basalt, compared the diversity. And also studied then there was the volcanic eruption, and then we also studied the succession of these communities over time.
And when was the eruption?
That was in 2005-06.
Okay. And that was just the seafloor spreading, just an eruption along
Yes.
this
Mhm.
line?
Yeah.
I suppose that's some of the area of the shinier rocks that we're seeing here. Is that a result of that eruption?
That's all, yeah. So this basalt that we see here is very young. So it's
Yeah.
basically, it was born 2005-06. So it's, a young basalt. And when you would go off axis with the ROV, at one point you could see like a change like that. So you can basically distinguish the old basalt from the new basalt because of the amount of organic matter that's deposited on
Yeah.
over time.
So a very new and young area for this spreading to occur.
Yes, yeah. It's a very dynamic area here.
Yeah,
Yeah.
yeah. And do you have who from your team is out joining you on this expedition?
So for my team, it's Alessandro. He's a master student, and also Fanny, who did an internship with me and also doing a master currently in Germany.
Right. And are they, Alessandro, what is Alessandro's focus?
So Alessandro, he's studying the copepods that we find here, and he's doing pressure experiments with them. So basically to find out the limits of life.
Yeah.
And these copepods are probably the most extreme animals on Earth, probably,
Yeah.
because we find those also like at the hottest places at the hydrothermal vents. And they are directly exposed to the vent fluids because they're small, they don't have any protection.
And so when we're collecting some of these biological samples and we bring them up into the lab, what kind of processes or experiments are you guys running on them on the ship?
Yeah, so when we take out the samples from the bioboxes, we first ensure that everything is like stored in the cold room to keep them basically fresh. And then the different groups pick out different animals to perform the experiments, and Alessandro would pick out then the copepods. We would sieve the sample to fraction the macrofauna from the myofauna, and then basically start sorting the samples under the stereo microscope, pick them out. Alessandro then puts them into small vials filled with oxygen-rich water, but also oxygen-depleted water, and puts these under pressure and also at different temperatures. And this is doing with a lot of specimens that we basically can find out what are their limits.
That's awesome. And then, is there anything that you'll be doing back on shore that you can't be doing out on the ship?
Yes, basically most of the work will happen back on shore. So we also preserve all the other specimens that we collect in ethanol. And back at home we will start doing genetics, so like the species, but also the connectivity of this species. So it's a combination of ecological work, like looking at communities, so what we find, but also how they are connected.
Yeah.
Are those copepods?
Those are small amphipods. So the copepods, they are also bright red, and sorry, this is my alarm, marking the end of the, almost the end of the dying.
Should almost hang out a little bit more and hear you talk about that stuff. That's
Well, now
I think everyone watching is finding that very interesting.
Now we gotta pump it up, right? So we still have a minute.
Yes, we still have 35 minutes
35
then.
minutes. All right, just getting warmed up here, folks.
Are you ready for us to pump it up?
Yes.
Now you guys will see this pump in action here. So somebody was talking about how the cans are made of titanium, you know? So some of the coolest engineering that you'll see on here is these arms, in my opinion. They're also titanium. But what's really interesting about them is you'll notice there's no hoses, right? And that's because inside of these arms, in the titanium, are etched channels that carry the fluid. So they actually don't have internal hoses. It's all internal porting within the metal. It carries it where it needs to go. Make it brighter here.
So first do the experiment to the back, and then we put it on.
That. So experiment to the back, copy.
So Alex Paris is using the manipulator controls here in the control room and looking at the screen in 2D, just the same as everyone else's, but we have a couple other views to kind of help with placing them and making sure you don't strike anything, and to be able to size it up correctly. Let me get another shot here. It'd be great to have. So we currently have the lights on the wrist of the manipulator. So you can see there. Nice light showing up. So reaching across the entire porch to do this. And it's 2.5 kilometers away, but it's, how much do we have on the drum at the moment of umbilicals, Zach, do you recall?
Just under 6,000 meters.
Yeah. So it's going through just about 6 kilometers of umbilical, so through fiber optics. So there is a slight delay. There's a little bit of latency. So controlling these things is a whole lot harder than it looks. I mean, you do get the hang of it, but it takes quite a while to kind of get good at this. And it's funny, over time, sitting here watching the pilots operate this, kind of think like, oh, like how hard could it be? I wouldn't have done it that way. And then the few times I've sat and operated some of these, I've quickly realized that being a backseat driver is a lot easier than actually operating these things. But look at that. You can tell he spent a couple of years working for Schilling.
So this should be pumping this dye out now, and we'll see this bag inflating if it's right. Looks like it might already be a little bit.
You can zoom in. Yeah, I can already see the stain at the dye.
So this would be, what is the dye made out of? Or what's in the dye?
What's in the dye? I don't know, like by heart, the chemical composition. I'm sorry.
It's a non-toxic dye.
It's a non-toxic dye that colors all live specimens.
So any shells that might be in there would be stained, and then I suppose the Riftia.
We'll have a picture board.
Yeah.
Let's see.
And Monica tested this for a very long time, 1 year ago, to find out how long the dye actually has to remain, that we ensure that all the animals are really stained.
Yeah.
I think it's going.
And you said the white part of the Riftia is made of chitin, is that?
Mm-hmm.
Correct? Yeah.
I think it's
Yeah, you can already see in the right corner here that the dye is moved towards the direction of the back.
Oh, So you're looking for the clear water moving in?
Yes, not moving like now that, yeah.
So there's a comment on here on YouTube talking about where the fibers connect to the boat. They're referring to the slip ring. Maybe talk about the slip ring and how that helps us.
Yeah, so the slip ring that's located in the winch is where the high voltage AC, electricity, as well as the fiber optics pass through. It is something that is kind of like a black box for most of us. We provide, complete the terminations with electrical and the fiber optics on either side, and we do some troubleshooting and diagnostics to make sure we have the appropriate light loss through the connection. I've never been into one. I hope to not have to get into one.
Yeah.
They're expensive, but they do a pretty critical and impressive job of what they do.
Is the slip ring we have on board from Moog?
I don't know off the top of my head, but I have been in one.
Yeah.
And it's not so bad except for the optical part. I don't like to go in the optical part, but like it's a lot simpler than you would think. It's just a series of dividers. If you imagine a cylinder of copper, and then along there's all these dividers that are made of like super insulating material. So it looks almost like a roll of, if you can envision a 3D printing filament roll, if you've ever done any 3D printing, it looks a bit like those rolls right next to each other with copper in the middle. And then there's wires that come down and touch that copper, and they use a brush. So they have like a copper brush with a bunch of bristles that touches that. And then on the inside of that is, on the other side of that copper, internally is the other side of that wire. So basically, as it turns, the brush never loses connection with the copper, so you can transmit the power through it. The optical side of it, like I said, I haven't gone into that. I think you pretty much have to send it back to the factory if you're going to go in there. But that's some sort of optical gel, I believe, that does the same kind of idea, where anywhere where you flash the light into that gel will be received or transmitted through on the other side, no matter the rotation angle.
Yeah, we have a much simpler one on our CTD winch that has no optical components to it, so a lot easier to clean and service that one. But still recommended to send that to me. Located in Halifax, Nova Scotia. Represent. Yeah, I was hoping someone was going to grab it.
Maybe you prefer to see the two. Maybe you prefer to see the two covered to the first chord to it's a good control too.
Yeah. All right, everyone, I've got some good news for you. Our esteemed multimedia technician Alex Havens has returned from a nice, well-deserved rest. Yay, Alex is back.
I don't like that at all.
Everyone on the ship is modest. So my name is John Fulmer. I've been your narrator for the last little while with everyone else. I'm the lead technician aboard here. I'm running the science team, but I am also going to go and put my head down for a little bit so I can come back for recovery and then handle all of our data at the end and assist the scientists in the laboratory as needed. But so far, they have not needed much assistance whatsoever. Pretty self-sustaining group. And here is Alex Havens. Oh, gosh. And I think your sister may have sent some messages earlier.
Mm.
But that was when you were in the chair, so I think you already answered.
It's working.
All right. Hello.
Yeah.
It's good to hear that John's been keeping things going. I come back and it's like in a full interview process, which is cool. All right, so we are still waiting on the dye to set then.
So we're right now pumping the
Oh, we're
dye
pumping back. I missed the whole dye setting portion. All right. So yeah, a quick recap then for folks that might just be joining and me. So for today's dive, we were placing experiment number 2. Yesterday, we scoped out a site for experiment number 2, and actually, you can see experiment number 1 in the background, the one that isn't filled with the dye right now. So what this experiment is, or rather the form it takes, is a mesh box. That mesh box is set down on top of basically an area where there's some venting fluid coming up, crack in the ground here. And the mesh is going to let the water through, so we can actually seal that down on top of the crack, and the water that's coming up won't like overpressurize and pop the box off. There was a question about that the other day. But once that box is on top, and we've sealed the cracks with some silicone, then this second box, which has this little hose running into it, was placed on top of that, and the whole thing is filled with dye. And then we sit here for a few hours while that dye cures and sets on everything that's in there, basically. So any critter that's under that box right now, as we start the experiment, is getting stained. Which means that if anything happens to come in, any new critter happens to come in, perhaps being transported by the vent fluid itself, it won't show that stain. And as a result, we'll be able to identify it as being something new. So it sounds like we are past that part of the experimental deployment, and now we are actually sucking the stain back up into a bag on the back of the ROV. Not that one. That's actually a view off of the back of the ROV, but there's the bag. So just sucking the dye back up into the bag, then we'll lift the outer box up and off and store that back on the ROV. And be on our way from experiment 2. And then we've still got about a couple hours, a few hours maybe, on the bottom here. Potentially, we're going to take a look at the objectives of the dive, and we might go around and collect some stuff. There's things get knocked around.
Everybody okay?
Yeah.
In the house.
Monica entered the room.
What does he say?
You need to get the medic?
No, it's like what does he say? When you work there,
Explosions.
quite something like this. There's nothing happening, then there's nothing working. Still the same.
I think tomorrow's dive will be looking for a deployment site then for experiment number 3.
And prep work.
And prep work for it, yeah. Okay.
Hopefully tomorrow we'll do all that, and then the next day after that, put it in the last box, right? And then-
Yes.
Then it's easy money.
Yeah, still some steps to go. So we still, after this 10 days of waiting, you still have to,
I'm sure you guys will
open
be
the
feeling-
box.
You'll be feeling pretty good after you get your 3 boxes in, then I would think.
I feel pretty good when we can collect everything that is in the box.
Yeah. Okay.
So especially the
But
collection
yes.
of the rocks will be another challenge. So I think this experiment has like a couple of challenges to overcome.
Yeah.
But right now it's going really well. And yeah, so in 10 days when we will recover the boxes, we first want to basically get the water out of the box. So we will use the pump, but like put a sharp object on it, a scalpel,
Yeah, the
to
needle.
punch in, and then get all the fluids out with them, the animals inside, either stained or not stained, depending on if they have them before or not. Afterwards, we remove the mesh back, and then we need to collect the rocks. And this will be the tricky part. So because we have already seen yesterday that it's really difficult to collect the rocks and intact, that you can also screen the surfaces for any new settlers. So this will be another challenge to come.
Yeah, collecting the rocks here, they kind of just fragment. Yeah.
And they're not very, if you don't fragment them, they're not very conducive to picking them up. You know? Like one big sheet almost.
Yeah, and after we've recovered the staining box, we will go a bit further north to already look for potential places for tomorrow.
Okay.
Oh, you might want to do the third box up here, huh?
Yes. So depending a bit on how everything goes with the time here, of course, but then we would like to go further north to Teddy Bear. It's the name of the site.
Teddy Bear, then?
Teddy Bear, yes.
Okay.
There's not much in between here and here, I take it?
Yes.
What about this? Is this active?
As far as I know, not. No.
Just a lava flow.
This is actually also part of the ASCT. So this goes like, it's a depression.
Toss that up. All right, we were just taking a look at a map here, so I can pull that up for y'all. So we're a little zoomed in right now, but here is Falcor 2, the ship. The ROV is down, right there. Little yellow rectangle. You can see we've kind of been floating here, or not floating, we're set down, but that's just some jitter. Mostly we've been down here, but tomorrow it sounds like going up there, and possibly if we have time today even, going up towards Teddy Bear and checking out up there for any potential deployment sites for experiment number 3. So when you're, putting together an experiment like this, where it has all these little moving parts and everything, do you, we're at the bottom of the sea, right? So you can't easily just practice constantly with that. How do you sort of visualize how this all goes together? Are there little sessions where you kind of sit there and think and then this goes down and then we'll put the box on top, and are there physical practice or kind of trial runs on land before you come out here?
Yeah, so some of the things you can indeed try out on land or in shallow waters. And I think what I really like also in developing this kind of experiments, that it takes so many small steps and a lot of thinking also from different people to actually come up with this. So it looks here very simple, it looks simple what we do here, but it took a lot of time to actually develop this kind of system. So first, of course, we designed the mesh box. That was rather simple, and the staining box also very simple. But then it took quite a while to look and search for material that is suited to seal the box to the basalt. And this took a lot of testing. So basically trying out different silicons, different hardness, softness, basically literally standing in the lab and just brewing things together, putting in to the fridge, because you need to simulate the cold conditions in seawater and testing flexibility under these conditions. The same also with the glue that we are using. Also there, just try everything out under cold conditions in seawater. Some parts, like the pump that we are using, they are of course pressure tested, because there's no way around that. So that's for sure needed. And and then basically the first setup was tested 1 year ago in Slovenia in the Adriatic Sea at 3 meters water depth. We could also see how the dye is really like doing its work and how well the sealing is. And actually back then we saw that the first solution that we had to seal off the box was not working. So then we thought, okay, no, this is not working, so we had to come up with a different solution. So as a first option, we actually were thinking about a curtain on the bottom of the box that would include some, kind of an iron chain, but like in very small iron balls. I don't know how to say it correct in English.
Kind of like a weighted curtain with like the hem of it would almost have weight. Okay.
So this was the original idea, but this didn't work well enough. So then we came up with this silicone solution. So the first testing was like 1 year ago at 3 meters water depth. And then we further developed, and then actually the last version we tested simply in a pool that we built up at 1 meter water depth.
Oh, excellent.
Where we tested like how the silicone would fit to different uneven surfaces, basically.
Yeah. No, it's way back. Like I think it was back when they were doing the syringe of the sealant. This is really a combination of like, okay, what can we get that's already going to work? And what are we going to have to make, right? So a lot of trial and error, and it sounds like you were just buying like different sealants, and you're like, does this one work? Does this one work?
Correct. So it's just basically also trial and error. It's like you have an idea, you want to test it, and then you try out different things.
Yeah. No, I love that mix of like
high tech and low tech.
Exactly, right? Like just off the shelf stuff. And like it's doing extraordinarily high-tech stuff. Like as far as if you told someone like, oh yeah, we're, sealing a box to the bottom of the sea, and they're not going to guess that you're using something that could be used for like sealing the bottom of a pool.
Yes.
But no, gets the job done, Fascinating.
Also the sponges that we use as colonization substrates. They cost like 10 cents.
Yeah.
And they work perfectly. So it's just it's the perfect material. You can uncoil them. You can cut them open to get all the animals out, and they imitate very well the interstitial spaces actually of the mussels, for example, the tubes. So we also know from the past that these colonization substrates, they are really simple, but they work really good.
Right. Yeah, because we have the sponges, and then there's also the like a little block of, I don't know if that's just acrylic or what that is.
Yeah. So it's called, what's the correct name? It's called TASC, tube form colonization device. We call it, I don't know if I can, baby traps, because it's supposed to. It's basically plates that are put on top of each other, and in the sides there are holes drilled, and the babies of the riftia tube forms, they like to settle in holes.
Okay.
So that's also designed by Monica, that she already also uses since, I think, 10, 15 years maybe.
Wow. Okay.
And that also proved already a lot of times that it's working really well. Because when you want to study these animals, you also want to look at them under the stereo microscope. And then it's very difficult to place like a full rock under the microscope. So it's much more convenient to have like basically a cube of several layers, of several plates that you can simply disentangle and then put under the stereo microscope and look at.
Oh, because you can basically take that central, like it looked like maybe a nylon pin or something out, and then you have a plate with the animals already on it.
So the cube is basically made out of 10 plates that are just put on top of each other, and you can unscrew the whole thing and like take one plate off after the other and scan for animals. Yeah,
I think some people saw it when we were deploying, and it looks almost like it could be a weight, but then obviously everything's attached to a chain, and it's like kind of bluish and clear. So that's really interesting. That's that sort of modular little tube worm lure almost, where they're going to say, "Oh, this is perfect," and just settle right in there. So excellent. It sounds like a paper was linked earlier about the use of those as well. So.
TASC, thanks a lot. TASC was the correct name.
Take a look at the bag. It's getting there. I know we brought down like 55 liters of dye the other day. Is that about the same as today, we've decided? Yeah.
Yes.
Okay. Quite a lot of dye.
So 13 more minutes.
13 more minutes. We'll probably hear a little alarm. We'll see. We'll see how it is. I know the other day, I think you just set one on your phone and it, like the mic just picks up this cheerful little alarm. So. Here's a question, and I'm sure it's a multi-layered answer probably, but you kind of got into how we'll recover this box. But the question is that when you pop that box off, when you remove the box, how do you know that the things under there won't just go like and get out from under the box? Are you expecting things will be pretty fastened down onto the substrates you've provided? But then you also said you're going to have to like punch a hole through the mesh.
So the first thing that we do, that we indeed like punch a hole through the mesh, and basically, to get all the animals out that are in the water in the box. And then this box is not really glued, so it's a glue to seal off the pool, basically. But you can remove it. I don't expect that it will be difficult to remove, to be honest. I think you just take it and put it aside. And then, we will have all the animals that have been there, like colored in red, and the others not. And especially then, when we look at the sessile organisms, there will be no doubt what is colored and what is not, and there's not, fast movement of those. So,
Okay. So I'm interested to see the kind of like the little puncture through. It's like in my head for some reason it turns the ROV into a mosquito, where we kind of are just like punching through the mesh and then sucking out the fluid that's inside. To try and get anything that's still suspended in there, I guess. And another question of why are we staying so still? Because we are attached to the box. And yes. The outer box right now, you can see that hose kind of going into the box, and that hose is actually that's providing. Well, it provided the dye, and now it's collecting the dye back up, and that hose goes onto the bag that's on Sebastian. And so we have to sit here while it happens.
How's it going?
Good. How are you?
Not bad.
Yeah.
So well, these two experiments are pretty close to each other. Again, tomorrow, and possibly even towards the end of the dive today, we'll be headed up further north to another little area of venting up there to look at where we might place experiment number 3. And if you haven't been with us for previous times when we were sort of planning out the sites where these experiments go, that's what the metal frame just to the right of experiment number 2 here is. We can use the manipulator on the ROV and actually kind of scope that around, and that's the footprint of the experiment. So we can plan out where exactly we want that box to be covering. Someone's curious about the dye. Is that just like the sort of stain that folks might be familiar with if they've ever prepared like a microscope slide or something more?
Yeah, this dye is also commonly used in science to stain organisms.
Okay.
Yes. Yeah. And it's not toxic.
Yeah. A large volume of microscope, like so many microscopes worth of slide or of stain. But yeah, these boxes will stay here for, about a week or a little bit more. I think experiment 1, we were looking at about 10 to 11 days of just sitting time on that one. To give enough time for any potential organisms to come up from the venting fluid inside that box. I'm looking back at it now. It doesn't look like there's any crab on it right now, but every once in a while you're seeing the crab kind of check it out. So definitely, they're always curious. I think right after we started work today, like 2 crab came over and kind of were poking at what we were doing, and then they left. So probably for the best. Have a difficult enough time, getting down the glue without a crab wondering what it is. So. I was looking around right now. I don't see any ballast weights in the camera, but this area is a relatively well explored area. And so as we've been cruising around, occasionally we are finding these little metallic blocks, and those are ballast weights from previous expeditions, not with Sebastian, but other submersibles that might require a ballast weight, and then before they come up, they kind of drop that off. Or they might use it to get to the bottom, I suppose, and then drop it off, one way or the other. So I expect we'll probably pass a couple of those as we're cruising around after we collect the outer box here. It's someone curious what this was. I guess there was discussion of red copepods earlier.
Yes, also, but this is a polychaete that you see here.
Little polychaete worm,
yeah.
Okay.
The copepods, they are much smaller. You can see them, I don't know if the camera can catch it. They're like 1 millimeter.
Oh, wow. Yeah. You'd see a little piece of dust going by.
And they also like to really sit between this, between the muscles and the tube bones.
Yeah. The thing
so when we passed by some black smokers with some pompeirums on it, there I think it could be possible also to film those, because then they're more exposed and you can see them actually.
That makes sense. I've really liked the little swarms of amphipods that kind of hang out in the vent area.
Yeah.
I think those are my favorite thing down here, which is not what I expected. Like everything down here is so cool, but I just didn't expect these. They make me think a little like flocks of birds, basically, kind of just at a beach riding in the wind. And they're just these little amphipods.
It's funny because the polychaete, it's crawling on a rifty tube. It's also a polychaete. So I have 2 really close related animals that are incredibly different.
Yeah.
I find this fascinating.
Completely different approaches to the environment.
Yeah.
Like, I'm going to fasten down, I'm going to build a tube, I'm going to stay right here, I'm going to get huge. And then you got this other one that's much more mobile and able to, move from site to site, but it's also quite small comparatively. I don't know what all John got you all discussing while I was gone, but early in the dive, there was a question about what sort of success we've had with the worms coming up, and then also the pressure experiments they've heard. Are we actively? I mean, like, that's the thing, right? Is the cruise isn't done, but science is constantly going on the cruise. So I guess what sort of process or what have we been doing with the worms as they come up, and is there anything that was kind of surprising with them, or any of the samples we've collected that wasn't expected? I know the worm we brought up yesterday was like meters long.
Yeah. Probably Andre, you want to tell your story, what you are doing?
Sure. So hello, my name is Andrea. I'm a postdoc and I'm here under the guidance of Monica. I did my postdoc with her. I was involved in sequencing and decoding the genome of the giant tube worm, Riftia, that you're seeing there, and also the symbiont that lives inside Riftia and the Riftia. So this is my first cruise, and I must say I'm pretty excited because I'm a bioinformatician. Normally I don't leave my computer or the institute in which I work. So it's quite like an experience actually to see live the animals in which I worked for so many years, but only look into the genetic data. So it's quite an experience. And what I'm doing here right now, I like everything about animals, but I'm interested to see what happens during the early development of the giant tube worm. So what I have been doing in the lab is we collect the animals and then I dissect the animals. I take out sperms from male tube worms, I take out eggs of the female tube worms, and then I put those two things together in a pressure chamber, and then ideally I will follow their development until the end of the cruise. And then I will have different developmental stages on these pressure chambers, in which I will use the samples to sequence their genetic material and try to understand at the genetic level how the worm is developing. So this is my main focus here on the cruise, on top of actually have a job as a data manager here, also helping Monica to organize all the data, because the amount of data that we generate in each dive is like incredible. It's, if I'm not mistaken, more than 2 terabytes of data each dive. So I'm helping Monica to organize this and all the scientists, how to distribute the samples, how to organize the samples properly. And this is like one part of the science that it's a little bit boring, but we need to catalog everything that we are collecting because we need to have control when we want to publish any scientific papers.
Okay. Thank you.
Yeah.
All right, and you also heard the alarm there that the time is up for pulling the dye back out of the box.
Stop the pump.
And obviously there's still some there, but a large amount has been collected back into the bag. As you can see, that bag's quite full now.
Camera back on. It is all the way back, yes. Okay, there we go.
So first things first, the pilots are going to turn off the little pump that's been filling the bag.
Zoom out, I think I'm all the way out in both, actually. Yeah. A little more reference.
Another task of engineering, figuring out how you're going to turn stuff on and off.
faster terminal, I would say.
Okay, now we move the staining box and put it back on the porch.
Yep, no worries, we'll do that.
I think 2 days before the claw was open.
Yeah, we're going to use lifter that way, because that way we can
Yeah.
control the tail,
Yeah.
it's a lot easier. Is that the here? Stop. Stop.
It's fine.
Okay, I'll stop.
Up just a little bit.
Thank you. I don't know, I knocked it down to 70 last time.
What's that?
I knocked it down to the next lowest speed. It's quite smooth.
Government is down.
Very good.
Do you want to do your cloth here?
No.
Nicely done. Looks like you tilted the fingernail there.
Well done.
Done. A few more grades. days yet?
That's not gonna lie to you.
Do you want to see your arm? Right?
No, I can see it.
Yeah, zoom out a little bit. Just up there. Zoom out your set so you get that here.
We got someone asking about the dye, if that'll be reused reused for like the next ones. No, we'll have a fresh batch of dye for that, because this dye does, obviously it's getting watered down, I guess is really what it is, and it's been used now, so we'll have to have a fresh batch for experiment number 3.
Check it. Porch all the way out. Okay, it's all the way out. Yeah. Camera back. Do you want me to grab that bungee?
So a lot of the porch space today taken up with these boxes. If you tuned in yesterday, right, we had a lot more bio boxes or boxes we could collect into. But today we needed to bring down the experimental boxes. So
Mm-hmm.
Sit it down. Grab.
Actually, that angle might work if you just turn it that way.
What's that?
The way you've got it gripped, if you rotate it that way, it'll actually fit that angle better. I think it'll be better.
You gotta spin the close around.
Well,
Was it the front or the before? I don't remember where it was.
I think it was on the top actually.
On the top? Okay.
No, it was no, the Fauna was definitely sitting in that direction. So
Yeah.
You're right, you're right. I just kind of dropped it, got the edge and then like,
Yeah.
it fell out quite nice actually. Good.
Here. What I want is to turn.
that's not so bad, yeah. Okay.
As you can see, the packing of the front porch here can be as much a challenge as anything else. Really utilizing all the space that we have and figuring out both how things will be placed on there, but also for items like this where we have to deploy and recover, how we'll be able to pack it back up. It's one thing to organize out one of these shelves on the surface, but there needs to be like an anticipation there that the pilots have as well of what packing will be like in the future. So trying to figure out the grips. You can see also the little bungee cord there that's going to be used to kind of re-secure the box down. You can see from this angle you can make out the little nozzle that the dye is delivered into the box with there. A little blue nozzle right about where the manipulator is on the other side.
Just right on the edge, and just it needs not going up, then that's it. Like lower, I think you need to go to the lower section. Almost there.
What's that?
It's almost there, just needs to touch down that corner, I think I'll drop in. Yeah, right there. That bungee. I think that bungee's still has to get in. Can I grab it? Yeah.
All right, so here's an example where the pilots sometimes will work together where one will do one manipulator at a time, or both of them at the same time, I suppose, one pilot controlling each manip. But in this case, you can also just freeze the manipulator like we have on the left there and swap out controls. So in this case, then it's one of our pilots controlling both manipulators, just one at a time, versus one manipulator being controlled by each pilot at the same time.
Can we tie it down already or not?
Well, we're
not
trying to
tying
move
it.
it because it's
Yeah,
stuck. We're going to move this bungee out of the road and hopefully it will move backwards.
Yeah.
And then we put the bungee on
Yeah.
top.
Box 10 on the bungee?
It's heading off the bungee.
Yeah.
It's not going back.
So I want to pull it forwards, I don't want to pull it back.
Yeah.
There you
There it
go.
goes.
That'll probably work now. It just takes that much.
Yeah.
And it's like, it's sitting there on like 2 millimeters of
Yeah,
metal.
yeah.
You may try to measure it. Yeah. Try and get down as low as you can.
All right, so bungee's out of the way. We're gonna give this corner another little tap there.
Just see this car in the back, just try and lift up, push in, see if it'll work.
We only have one box.
I know that, it's okay.
All right, swapping back over to the other manip. So I'll just do a little recap here real quick for anyone just joining us. This is live footage that you're watching from a remotely operated vehicle named Sebastian, which is currently about 2.5 kilometers below the surface of the Pacific Ocean, 2,000 kilometers to the west of Costa Rica, about 1,000 kilometers south of Mexico. And we're in a hydrothermally active area. That's where hot, mineral-rich water is actually streaming up from below the sea floor, creating a environment where we have these large tube worms and all sorts of other critters around. But scientists are interested in how these animals get to these sites and how they move around between these sites. So today we've been placing an experiment down here. We are on the East Pacific Rise, near a vent known as Tika Vent. And currently we're just packing back up from the experiment that we deployed today. And after that we're probably going to go collect some samples. We've got, let's see, maybe another hour and a half to 2 hours on the bottom here. I mentioned this is a remotely operated vehicle. That means that no one's inside this sub. Instead, we are watching by camera over a long 6 kilometer long umbilical tether that goes all the way back up to the surface and onto a ship, the research vessel Falcor 2. And so we are controlling the submersible from on board that ship, even though it's 2.5 kilometers below us.
Yeah, but it's also before.
How'd you only got one corner left. I don't know where it's coming from.
Are we live? I think so.
Yep. Yeah, it's just a quiet moment, that's all. There's a question, just double checking that we're live. We are indeed.
It's called something.
So if you happen to be joining us, and maybe you've just joined, you can also ask questions, and we'll try to answer those as we can. Right now, everyone's kind of just focused on getting this box packed back up. But if you're watching on YouTube or Facebook, feel free to type a question in that chat if you might have one, and we'll try and get that when we see it pop up. And also, if you have to go, if you've been watching, but you're like, man, I wish I could watch the rest. All the recordings from these dives do stay up on our YouTube channel in full. And you can also follow along with the expedition in 2 other ways. We do have other social media links that you can find down in the descriptions for these videos. But you can also follow the hashtag #VentUnderworld. It's hashtag #VentUnderworld on Twitter, where there's been posts even by the scientists on board, as well as other people who are watching these expeditions, these dives, and they're posting photos and little clips from the dives. So you can follow along that way. But you can also go to schmidtocean.org. I'll post the link up here in the chat momentarily. Schmidtocean.org will have a page for each of our expeditions, each of our cruises, including this one currently, the Vent Underworld cruise. And you can learn more. You can get a little bit of background on the expedition, background on the area, information on the scientists and crew on board, as well as a series of blog posts written by the scientists themselves. So I'll post that in the chat here momentarily.
I want to go over it, not around it.
Yeah, I understand.
There we go.
Oh. There we go.
Yep. I'm gonna get there and pull it a little bit.
Like strapping a tree down on top of the car.
Close it up.
All right, so now that we're finishing up our securing of this box and packing back up from deploying experiment number 2, we're gonna be kind of scoping the area a little bit, cruising around, looking for perhaps a couple samples, couple collections, take some readings before we head back up to the surface. Yep.
I don't know.
Thank you, Arrow. Like this. Okay. Applause for your boss.
You can also put the second highlight.
Will do.
So they're just taking a look at the experiment here now as it sits. We also have that frame off to the right. We'll be grabbing that before we're on our way, I expect. That's how we... that's true, we might just use it tomorrow as well. I mean, we will use it tomorrow, certainly, but what we ended up doing last time is we left the frame in place, just where it was, and then we came down and got it the next day before we went and scoped out the site for the next experiment. So we do have one more of these mesh boxes to be placed, and tomorrow's dive will be mainly just looking for a good spot for that, and then opportunistically exploring the area.
All three?
Yes.
All right, so before we're out of here, they're going to take some water samples, and that's going to be with our Niskin bottles. So for anyone unfamiliar with Niskin bottles, we're talking about basically a tube. It's a tube that's open on both ends, but with a spring-loaded cap on both ends. And so when the ROV pilot triggers these little switches off to the side, you'll see them.
34 and 35.
Those spring-loaded caps snap into place, and they trap water inside the tube wherever the ROV might be at that time. This is a pretty common instrument used in lots of different oceanography and marine biology.
Number one's flat.
And these little switches, I believe, were printed on Falcor too. We actually have a little printer. So if there's a particular little part extension or anything that we need. Oftentimes our pilots will try and figure out how we might be able to print that on the ship.
Then we need to pick up the frame.
Yep. Just double check it all.
There's that thing behind there.
Yeah, okay. Me grab the frame as well.
Yeah.
Checking if you landed with the other box, so I was a good bungee that's up.
I don't know if it'll be tight enough to do anything, but we'll try.
Might just have to hold that on the way up.
Oh, throw inside the box. I should slide it out, drop that.
Seems the handle.
It's on the far side, kind of angled down. Yeah. So they are going to collect up the frame here. There's a handle similar to the handle that was on that box that we just picked up. It's on the back side of the frame from where we are, though. So some folks noticed that the manipulator grips are a little bit different, or the jaws are a little bit different on each of the manipulators. Those can be modified. In fact, we have a different set of jaws on the port or the left manipulator than we had on our last expedition, for example. But on the right side here, you can actually see on the starboard manipulator that we actually have little bits of rubber there for a bit of a softer grip. But at the same time, there's also a couple cutting edges in there where blades can be loaded in. So if we needed to do something like snip a coral or a sponge, we have that little blade in the jaws.
See if we put that frame, we can actually slide it in to where the box is and just let it sit inside that box. It won't go anywhere.
I think it doesn't fit.
No?
I fit behind it.
Okay.
Like the frame and the box have the same size.
Oh, they're exactly the same size. That's a shame.
Probably could go, I don't know, like here. Yeah, I don't know.
It's not
Well,
like that.
It has to go between the milk crate and the big pile box. This is the place.
Alright, let's give it a shot.
Allocated.
Should we come out here for that?
See a question about Midwater today, and I think we're probably going to use up all our time on the bottom to take advantage of a little early completion on this particular experiment deployment, and we're going to scope around down here. So a little more bottom time, but no Midwater time today, I don't think.
So it fell in, okay. Yeah.
Good. Okay, then we start our transit to.
All right. Are you happy with that?
Yes, and I think we just need to watch it a bit
Yeah, it's
as
alright.
we are
If it looks like it's
traveling.
going somewhere, I have an
Gotcha.
idea.
Sorry?
So if it looks like it's going somewhere, I have an idea. It might not work out. So we go through it and strap it, but it might be too loose and it'll fall off.
Yeah.
Should be fine.
Okay, good. Then we can start our transit to Teddy Bear.
All right. I'm going to put your map back up.
And we had this here, the coordinates. I think John already entered them. Like the one that, yeah, these ones. They should be already in, I think.
So,
there's Teddy Bear.
here's your map again. We are currently down at the bottom of this map. You can actually see where Falcor 2 is off screen. Down at the bottom, there's a bit of a red circle there. We are a little yellow-orange rectangle, kind of in that mess of waypoints and markers. And we're going to be headed up north towards Teddy Bear. You can see it up there. So that's the site they're hoping to place Experiment 3 near. So we're going to head on up that way right now.
Where we going to? Teddy bear. Or just teddy bear. Single teddy bear, not teddy bear.
I'm going to actually. Just kind of the yellow in between.
We're at your RV, new waypoint for it.
RV, go ahead.
Okay, that's a new waypoint for you. Due north.
All right, sweet, thank you.
Thank you.
See again?
So you got a lot of setting in the water when turning your lenses off, doesn't really change.
That we've seen quite a lot of, even just in the area we were just at. But scattered out over the rock that we're traveling over now, occasionally you'll see these little white squat lobsters. They look very much just like a little round crab. Might also encounter some fish along the way. There were lots of eel pouts, especially near clumps of tube worms, so we'll keep an eye out for them. There was a snailfish yesterday, I believe, just at the end of the dive as well. Here's a large anemone. We've seen a couple of these now. We saw one on an earlier dive. And this terrain is just fascinating. There's one of those blocks I was talking about. So that's a ballast weight from some previous expedition, not us. Weigh themselves down, descend quicker, and then when they no longer need that ballast, they'll leave it, and it will deteriorate. It is metal, so it might be slow, but it does corrode in the seawater.
My sheet of paper. Is this one over there? With the coordinates on it?
Coordinates are somewhere. Yeah.
Yeah, that's what we get for after
Mm-hmm. Yeah, he's gonna slow down a bit.
Okay. Just see what we find there.
So, the reason?
I don't know. What, do you know, is there a reason why this is called teddy bear? I mean,
Yeah, because when they found the site, it looked very new and you had fuzzy white bacteria, and that's why they called it teddy bear.
I'll take that.
It's supposed to be like two worms.
all right. So, anyone who didn't catch that, teddy bear, the reason why is when they first found the site and were naming it, it was covered in sort of a fuzzy nature. It had a fuzzy nature to it of bacteria. Relatively a new site at that time.
You know what is also looks new now compared to when we were.
We have a question on whether or not Falkor has to move from site to site. Yes, the vessel has to follow the ROV wherever we go. We are tethered, and we can pay out enough tether to pretty much get anywhere we want, but then that would become very unruly and dangerous for both the vessel and for the ROV. So we try to keep our umbilical to a certain distance, and that's based upon our depth, our length from the vessel, and other factors. So whenever we have to move large distances like we are now, we'll have the vessel move along with us and keep our umbilical about the same length the entire time.
That's true. Ich bin schon zufrieden, wenn wir jeden Tag drin ist. Das ist gut.
Yep, I can actually put up that map again, and you'll kind of see Falkor 2 creeping along behind us. So we're actually just off the top of this map, the ROV itself, but you can see that that green trail there is the trail that Falkor 2 has taken. So it's just creeping along.
A little bridge, you can speed up that little bit.
Speeding up 10.5.
Yeah.
Yeah, but this, yeah, but sehr polite. This middle from small.
Ja, hier ist der Anemone.
Now that anemone looks familiar. That's the one we saw before.
Oh, now this is only shiny.
So a different type of map. We were looking kind of just at the map that the pilots use for piloting along, but we also do have bathymetric data as well. So this is kind of looking, this is actually looking back from the way we came from, I believe. So this is looking back down to the south, and the ROV is off the bottom of the screen from where it is now. But you can see the little trail from where we dropped down, and came down from above. This is where we just were working, and then if I spin this around, you can see where we're headed now.
Look up. I looked at the screen and I was like, oh.
So there we are on our way. And yeah, these bathymetric maps are real fun, but also very useful to sort of be able to visualize the terrain before we get down here. So we are nearing Teddy Bear. Yeah, this area is a spreading area, and the East Pacific Rise extends quite a long ways. But I think I'd seen that at its max spread rate, it's something like 6 inches a year, over 10 centimeters a year. Yeah, no, that's a significant spread. Yeah, the bathymetric maps definitely come in handy. Again, this area's been well explored, so in this case, we already had real nice data. But if you tuned in for the first dive, where they were hunting around for hydrothermal vents, right? That was a multi-step process where they were looking for signs of venting, and then they were sending down autonomous underwater vehicles, or AUVs, to then map areas that we thought the venting was at in real fine detail, so that the pilots had good maps on the way down.
Stefan?
Ja. Das sind die Koordinaten.
Ja. But still see a little bit of rocks.
Yeah, but the spreading right here at this exact site, I'm not too familiar. I want to say that the one that's like 6 inches is down by Easter Island, because this extends. That's a cool looking site.
Can you see Stefan?
Yeah, I have to. It looks a little different from what I remember.
All right, so we do have the tube worms again, and the squat lobster that we were talking about, but looks like we've also got some little eel pouts hanging out here.
There should definitely be weight stacks. There should be weight stacks from the previous deployments.
Okay. Okay. Continue. Yeah.
Should we check out Eastwall on our way?
The prime side is this.
Yeah.
Right.
I mean,
We can go like towards
cool.
the north and then a bit towards the east, so basically fly over Teddy Bear. Or whatever the name of the site is.
this is for sure the this was where over. This is what
That's
was
a big
locked.
squatty.
This is your coordinates. See the
It's a
yellow.
little bit in Teddy Bear too.
No. This yellow locking is from today.
Okay, he's cool. One Teddy Bear too.
But this was doing the side.
So the temperature here definitely did bump up a little bit, from below 2 to over now 2.5 C. Obviously, down right where those venting fluids are coming out, that is significantly warmer again. So, but we have this nice little cathedral of worms going on.
The location we asked people walking, did you name it Teddy Bear 2 or Teddy Bear from the day?
I didn't actually do that. Check. So you want me to head over towards East Wall?
Stand by,
Yeah.
Russ. I see if he's still going out. He is.
Hold on.
Steep wall.
Yeah, coming up nice and easy. Good on this one off.
Bridge ROV can have you like move to that L4 2 waypoint pretty fast. We're about 170 meters from you.
I think Teddy Bear 2 is
New waypoint, 170 meters.
No, it's the same waypoint. It's the L4 2 one north of you.
Alright, north of me.
That was
Okay, just coming up the wall.
Yeah.
Yeah, probably my mistake that I mistook station for the waypoint.
I'm not really sure what that is. I think it might have been from us earlier, maybe. I don't know. But yep, you're on it.
Yeah, we'll see if we get 1 knot, 1 2 to hit.
Cover that. Thank you very much.
Still up, good.
Yeah, this one is giving it long, so this one is diameter.
Obviously, a very different terrain over here from where we just came from. So, to reiterate, the site for experiment number 3 still needs to sort of meet some requirements. Of course, we need venting, but it also does need to be relatively flat and level. So, this terrain, a little different, but we'll probably find a good spot for it. Again, tomorrow's dive is primarily going to be about finding that that deployment area if we don't somehow just stumble on one right now. So.
Stefan thinks that we were passing Teddy Bear 2, but I think we were going over it.
I don't think.
But there was nothing on the right
But
side.
the crack, there's nothing. You see the track? This is nothing.
Yeah, but it wasn't this side.
Okay, we can.
Little rubble pile there.
Very steep.
Was this part of that?
East Wall.
Can Russ be where you're available?
That's
That's all about.
Was this part of the eruption in?
I'm facing the wall.
Yep. Sorry, pilots are currently keeping an eye on Falcor 2 behind us. We were a little speedier than they were. Is this area part of that eruption from 2005, 2006?
Yes.
Yeah, okay.
And actually, Eastwall was one of the sites that was not flooded on top because it is so high.
Yeah.
But the venting stopped in 2006, so we had like there then dead tube bomb clumps. There was that, and also like what's the influence of actually the communities that can feed on all the biomass that Rift here leaves behind.
Yeah.
Amazing.
This is so pretty.
Wow. So yeah, relatively new then. 18 years.
Go back to Teddy 2.
Just circle back, yeah.
Yeah, I'll draw back then.
I could look at this.
It's pretty neat.
Oh, it's super cool.
I got actually wood power. So it's the eruptions.
This is cool. just to show you our situation camp. This is looking down, down this wall. So there is a bottom, but it's down there a little ways.
Totally cold. This is really.
Lots of the squatties just hanging out. Chris is disappointed I didn't say that they were squatting.
Depth of this side.
No.
Okay.
I love when they just position themselves like right at the overlooks here.
So there's so much, production events.
Mm.
Back there. This is where we've been before. Now we see it from the top of. Oh no.
Yeah, this is where we were.
This is what we've seen before.
Now we need to go.
No, we came also from here. Yes.
Yep.
Yes.
Yes, but it has to be now on the eastern.
I made now a circle. We are back at where we have
It has to
been.
be on the eastern side. You have to look at the eastern wall, no?
But we look towards the northeast at the moment.
Right. So if I look here, you should see it, no? I mean, teddy bear too, because this is what we were already.
Yeah.
This
No,
is
that's
teddy
right.
bear. So you need to, if you can circle, it needs to be somewhere.
Probably it has been here because you also can see here
I
all
mean,
the.
it could well be.
I can see
Scientists
nothing,
are
Yeah.
currently looking
but-
at the
Oh,
map
yeah,
and where we are,
right
and
there. I mean, right there,
discussing
you should see it.
potential
Yeah.
target sites to visit.
This is it now.
I mean, this side could be open, but we need to find.
Yeah, now that we've kind of settled into this area here, anyone just joining us, you are watching live footage from a remotely operated vehicle named Sebastian, which is currently streaming footage from about 2.5 kilometers below the surface of the ocean. It's doing that. It's bringing the footage up on an umbilical cord all the way to the surface to the research vessel Falkor 2. And we are up on Falkor 2. That's where the pilots are for this and the scientists for this expedition. And then we stream it out to the web, where we love folks to come and explore along with us. So the area that you're looking at in this stream is part of the East Pacific Rise. We're about 2,000 kilometers to the west of Costa Rica and 1,000 kilometers south of Mexico. And we just left a significantly flatter region of the rise here, down by Tika Vent. We placed an experiment there earlier today. We wrapped that up not too long ago and have headed north now towards a venting area known as Teddy Bear. And there is lots and lots of interesting geological features here.
Yeah, okay. That would be good. It should slow it down and it should drop back to the waypoint in a second.
Okay, that's good. That's it. So I did that. Thank you very much. That was Teddy, yeah. That's cool. That was Teddy Bear.
So it was discussed that a lot of this rock is pretty fresh. There was a new eruption or a flow event here in about 2005, 2006, I want to say is when it was.
That's a different site.
But we just got here. We are towards the end of this dive, so we're going to spend a little time here, but then tomorrow we will be back in this area to hopefully locate a site for experiment number 3, which will then get placed on the subsequent dive. And here are some of the giant Riftia tube worms that are, I would say, probably one of the most recognizable organisms found at hydrothermal vents, but we didn't even really know about this sort of hydrothermal community until about 1977. Lots of eel pouts here amongst the worms.
This is pretty accurate.
Sorry?
This is pretty accurate from the group application. It's also newer.
Yep, being tube worms, you might see them draw themselves down into their tube. So the white portion is the tube, and the red lipstick-like portion, that is a gill structure that comes out into the water. Oh, fantastic question. What do the worms survive on? So these worms are fascinating in that they have a symbiotic bacteria that lives within them. But when they are larval, when they're juvenile and they haven't grown yet, they actually do have their own digestive tract, but that goes away and the symbiote takes over. And that symbiote actually converts the minerals, the chemicals that are found in the vent flow, and turns that into energy. And obviously the bacteria uses some of the energy itself, but the worm gets any excess. And lots of the animals here have relationships like that. So the mussels that you can see on the side there, they also have bacteria that grow inside them. So these relationships are complex, but yes, it's a form of chemosynthesis in an area where there is no sunlight reaching down here. There is trace food that comes down from above in the form of marine snow. Kind of looks like snow, but it's mostly dead things and waste from still living things. And that can come from an environment where there was sun to feed that environment. But down here, that energy is mostly coming up from the rocks itself.
Mussels,
Scoop in the dashboard. There's one.
scoop.
Just scoop. Yeah, wherever you can get to it.
Possibly the same as well. I'm going to bring the camera back so you can see it here. Try to show some weights here. Say again? Do you want to see it?
That's not true. It's fine for this. Look what that's framing away.
it's down like this. This is it. If somebody else.
So we're going to try and take a couple samples and collect some of the organisms here before we're done with today's dive. But I mean, I can tell you I'm really looking forward to tomorrow's dive, just hanging out in this area. And of course, I hope everyone watching will join us as well. We're looking at diving roughly about the same time.
Yeah, but between 2014 and 2019.
After that,
No, but they maybe not, you know, and this site is just not right now, or it was even more recent, maybe not. We only have one box, so we have not two.
So we've been launching about 6:30 or so in the morning our time, 6:30 a.m., getting down to the bottom anywhere between about 8:30, 8 to 8:30. And we are currently on UTC -6 is our time. So. Likely won't be any Ascent footage today. I think we're going to spend out the rest of our stream time on the bottom here. So unfortunately, no Ascent today, but lots of good bottom time for now.
There's obviously a lot of misunderstanding both sides.
You're pretty far down there.
Oh, that's weird.
So,
It's all just clumped like that, yeah. Just didn't anticipate the whole sort of blob of muscles moving there when you touched them.
Pass off your board.
not really.
Yeah, with an ROV like Sebastian, where we're actually powered from the ship, you know, the dive times can really vary. We've been doing relatively short dives compared to what can be done in the industry. Something like oil, they can actually be diving for days on end, weeks on end even, without bringing the surface, or without bringing the vehicle to the surface.
We got one.
Yeah. Probably you could use instead the Manipulator because we want to get the associated community, and if you grab one muscle.
Yeah, all said, we're doing about 12-hour dives with an 8-hour bottom time, and we stream pretty much as soon as we hit the bottom. And then since we're staying just about 8 hours, there's not usually any leftover time there for us to be doing Ascent. But rest easy knowing that if we do happen to spy anything super crazy on Ascent, we'll be sure to let you all know. So far, Ascent has been pretty quiet on this particular expedition.
Probably take the other. No, stop. Probably take the other arm without the red thing. Yeah.
Yeah.
Because this one. Okay.
No muscle left behind. Let's get right there, because I'm just going to flip it over. One first.
while we're working here, I kind of just have fallen in love with the view out of the back here. So I'm going to kick that up for you all to see. Just a fun little framing there. Just a couple little squat lobsters peering over the edge down at the sub. All right, I'm going to hand it on over to Juliana for the rest of this dive, but yeah, we'll see you tomorrow as well, and I'll see you then. So enjoy the rest of today's dive.
Probably if you're probably grabbing here somewhere, then
Yeah, it's got a whole bunch.
a bit from below.
You say try and skip it from underneath?
If that is possible, I don't know. Nice.
So this muscle aggregation is so deep, or do you see any place with a rock where you could walk and pull? No, nothing, good.
Yeah, for sure like half a meter high.
At
because
least,
they,
yeah.
Not,
Hier kommt schon wieder, schon. Attacke.
Oh my god.
Attack.
Oh. He's like, don't worry, I'll help you out.
Whoa.
if you go in a bit with the arm, because they touch together with all the byssus threads, and then you can. So basically, don't have to smash. Yeah, it's very difficult.
Yeah.
I just think that they hold together then in the end on the at the bottom.
Yeah.
They'll break this one. They'll break the arm, they wouldn't break up that.
There you go.
Right. No, no, but you're right on the last of the walk for the look at the walk, for example, just for founding, because you would like to get into a really big walk looking.
Right.
Oh, look. There's
Oh, rope's cut down.
object got all this little box.
Okay, hello everybody, this is Juliana. If you're just tuning in with us, this is SOI Dive 547. Feels like just a few weeks ago we were on 505 over in Puerto Rico. So we're now on the East Pacific Rise. Specifically right now, we're diving on Teddy Bear Vent. We started the dive at the site of Experiment 2. We put down Experiment 2, dived to the surface, and then once that experiment was complete, we had some extra time to explore to the north and head to Teddy Bear. So Teddy Bear is called Teddy Bear because it has more recent active volcanism here. And so when it was new, there was a like fuzzy surface to the whole vent. Looked like fur, so they called it Teddy Bear. So we probably have 30 to an hour left of this dive. And we'll continue exploring Teddy Bear, and we'll be back diving at this location most likely tomorrow.
Chris, you want to say with that?
We gotta do that box is jumped off.
Something that is catching that box.
Yeah, whenever you leave off, reports are earlier it jumped. So,
Okay, it's clear now. It's just the rope's catching.
what's that?
The little rope handle. It's clear now.
My crab is holding a little piece of something. Broken muscle. This is my snack, and I'm taking it over here.
Can you go in with one and with the scoop and with the other one on top?
What's that?
We could try.
What's that?
Use the scoop and use our arm to try and scoop it.
Like to hold it basically to.
No. They didn't like that.
They want to do their buddies.
You just need to get it set up.
Nice. Okay, we're gonna try to scoop some of the mussels.
As you have been before. And try to put the other hand on top when you. It's a rock. Can you grab it here?
Sorry?
Can you grab it here?
Give it a try.
It's also clumped things together that probably you can grab it here. This one here.
There you go. I think you can turn my lift a little bit, easier. Closer. Push it down.
Yeah, I can see.
one more time. There you go. Take the very end, but pretty close. Yeah, okay.
Nice.
One more time. I'm gonna follow up to the right. Alright, that should be good.
Okay, sorry, sorry, the rock, you were saying this one here?
I think this here. Yes.
She's got a grab of it.
You can grab it here. And they're attached to it, so if we grab the rock, we also get the muscles.
You got these?
These are also good, very good. Like, yeah.
So, well, I just get out of the way. So you're happy whatever you want to do.
I need to zoom in because I can't see it. So, what are we thinking?
Can I? Is it okay that I?
I'm sorry. Sure.
Sorry. Can you move this a bit? So now I don't see them more like a bit before. Okay, but I don't know. I don't see it anymore. Probably was wrong. Ah, yeah, here. That one, yeah. Here. That's probably too big, huh? I guess. Too.
I think you've gone too far. And it's the cable. Stand by, stand where you are. There you go.
Okay, got it.
It's right there. 15 straight on the cable. Going that far down.
I can't get that far, but it's just
Well, you can't.
You can't reach, but okay.
If the elbow instead of
Yep.
shoulder.
Then we put the muscles from the scoop in the box, and then we can probably try once more to scoop them. And then it's good.
Yeah, instead of going shoulder as much, just elbow
Yeah.
more, because if it goes that straight, it
Yep.
that would fix that problem, but I guess we get that.
Tongue off.
Mm-hmm.
Push them out, nice and easy. Okay.
Alright.
Camera's already in.
That should be fine. I don't know. I don't know if you want to know the way it might sit in the porch.
It's more porch.
Yeah, I think it's still under the porch.
Should be clear there.
Yep, they're good now.
There's one with these neon photos on. I can show you if they can grab it.
The one we just had?
No,
No.
but I won't now. Now you can see what I can show you.
You got a few in there, right?
15 Minuten. Ja. Das wollen sie nicht mehr anders machen. Da liegen noch gar jetzt so Lose. Das ist ja okay.
Cool.
Very good. You can do one more scoop to
More
big
scoop?
way.
No problem. Okay, watch that.
I don't want to go down, so I don't want you to go down that far.
Okay, so.
I was going to the east, the water.
Yeah.
Can you bring the port rail? I don't know, maybe it's closer, see if
Port rail.
Yeah, yeah. Not much, not much.
No, it's got nothing. Maybe closer to the left, yeah, there's a big chunk down. See this one, just, yeah.
Oh, that was cool. The crab is slowly scaring the Rifty as it climbs up them.
Is it going to another scoop? I'll show you the look.
And then in the bottom left, some crabs are fighting over some mussels. It's cool to see.
Ja, das will man da. Ich glaube, das ist mit den anderen, das ist nicht das, was diese nicht, diese das
Very good. So this will be sofort.
What we need in the future is smash around.
Ja.
Das ist jetzt alles.
Okay, now then, push on it. You put your arm over. Okay. That looks one.
Zoom out on the
Great. Very good. Then, if we look back,
Yeah.
where we have just been.
Sorry. Very good. Just gonna show these.
There was a small rock.
Right. Yeah, it is.
You want any more mussels?
No mussels, very good with mussels, but please keep the scoop. Keep it for a moment.
Okay.
Because we've seen on the rock some special.
Ja, heb zo.
This one, yeah. This one, go down, no, go down, down.
Zo
Yeah.
I
have Monica's settings, so I can
do it for you.
I like
to do it. This one. No, not this one. The next one. This one. This one.
Okay.
This here. It's not the same as the other one.
So you want this?
Yeah, this is the
one
this.
you want.
Yeah, there are several on it of this Neomphalus species.
So probably if the scoop is broken.
Yeah, I think also. Just from below.
Alright, well, so you can scoot that road like this.
Which one?
The one right in the middle of the screen.
Okay.
Keine Ahnung, wie, aber weil das ist ein PhD. Also mal schauen, wie viel das drauf sind oder was, aber keine Ahnung. Ich weiß nicht, ich kenne sie, ich habe nie auf die Hoch gesehen. Ja. Die sind total stationär, die bewegen sich kaum, die machen richtig Flug in den Stein, aus irgendeinem Grund. Well, actually, when we get it, you make a separate sample then, but wait till you get it.
Do you want me to see if you shut the other one in the other room?
Hold on.
I don't think it's only one, but it's one. Yeah, completely. I don't know, can you
Almost. Yeah. Just they are, just
They're right.
Nice, yeah. Absolutely amazing. There you go.
Great. Okay. This is really a new
Wow.
sample number for this because it's Ian also needing them.
Would you like it in the box?
Yes, we have no other place
Yeah,
to.
no worries.
Here we go. 27. Goes on the same firebox one.
This is how we do it.
Neon 5.
Oh, can you use our buddy?
Okay, by one.
I use what myself really.
2.
Great. Super. Okay, finished with sampling.
Fantastic.
Put this in the box.
Yeah, you can.
No.
Why not? Oh, yeah, sure. Oh, you can put the shuttle in the box.
Yeah, yeah.
Okay. It's important that the frame and the box stay on the rock.
Even if you lose your own stuff, our stuff.
Whoa, that's a bit hard. That's heartbreaking.
That was fun. Of course, we don't want it.
No, nothing's gonna get lost.
Probably can you grab the frame?
The frame, can you grab the frame with the...
What I would do is I would move the frame so it's over the box entirely.
Oh yeah.
That's.
But against the neck on the touching the.
And then we poke the.
How about this? You put the torch in, I'll
Can you
put the
store?
arm against it, and I'll hold it like that the entire way up the
Yeah.
arm.
You hold it.
Yeah. Not push, not like that, but
I'm
just.
just gonna push up against
Yeah.
it, and the arm will move.
I'm just gonna put it over the box and slide through.
It's not a lot of work.
So it's like many lobsters now. We're getting lobsters again. Just hitchhiking the stage.
John Gale. Awesome. What? There was no the one in the firebox jumped out before the closing. He did not open the firebox. This time we were sure it was sealed.
No, it was sure it was here.
Yeah, in the next grade, yeah, in the next grade, anything can happen.
Okay, we're just stowing our porch so that it'll be okay through our ascent.
Just routine the rest of it.
Last little sight of those crabs fighting over the mussels. There we go. Looks like someone won.
Yeah, for tomorrow. Yeah, because this is not suitable for us, and we need to check it out. So.
Just over there. That's right.
Alright.
I can go and see the experiments in them because these are not to show anywhere. Sorry?
Jetzt Schnee hoch, und 200 Meter wieder raus. Eben ist sowieso.
There's some mussels in the big wire box. So you just need to just keep.
Okay, we're doing a quick watch change. Thank you, Chris. Thank you, Russ.
Pretty much.
Great sampling.
Okay. Very well, but see that.
Could go because this
Okay.
Great, Jarl, you got dropped off now.
Copy that already, I'll put it.
300?
Wir wissen, wo es ist, oder kann ich nicht? Oder fangst du dort an, dann, wenn du dann, oder? Oder hast du das für uns gesehen, wo es ist?
Yeah, it was like.
Okay, we're gonna get our lighting fixed for you guys a little bit here. And then we will give you a little bit of Midwater. We're restricted by our time on YouTube. Actually, it's technically Facebook. We get capped at 8 hours. So these dives have been pretty much 7.5 hours. So we don't want to restart a stream just to have only Midwater. But we will give you a little bit more of the Ascent.
Weil wir gesehen, ja. Gesehen, den Marker gesehen.
Yeah. Das ist ein Experiment. Das ist ein Experiment.
Aber gehst du nochmal darauf, oder?
Würde ich gerne, ja, mal hingehen. Weil die dann morgen hin. Ich meine, das ist relativ.
There we go.
Ich weiß nicht, ob das an der Seite ist.
Ja, da war ja keine Dings mehr, keine Coupons mehr.
Ich weiß nicht, ob man nicht so genau sehen. Ja. Aber Schienen sind
Wow, look at that basalt. Okay, we're just repositioning ourselves so that we're kind of lined up for recovery, and then we'll come straight up. Okay, what I'll probably end up doing is ending the Facebook stream shortly here. I think I have about 20 minutes left. And then I'll let YouTube go for a little bit longer. But thank you all for joining us for this dive. We had a successful Experiment 2 deployment. So we will be exploring this area more tomorrow around Teddy Bear. And then throughout the rest of the cruise, we'll be coming back to our experiment sites and checking on them and seeing what is happening with any new species or undied species in that area. So we're gonna go off mic and see you tomorrow. Hello, I'm back. For your information, we're just gonna turn on the pump and get rid of the last of our dye. This dye can't be reused for the next experiment, so we just have to get rid of it. And we prefer to get rid of it in water because it's not harmful, as opposed to on the deck of the Falcor 2. So you'll be seeing a lot of red dye as we make our ascent. There's nothing bleeding, it's just dye. Okay, enjoy some blue water. Okay, we are reaching our limit on Facebook. So if you're on Facebook and you would like to continue seeing some blue water, we will just refer you to YouTube at Schmidt Ocean Institute. And you can continue the ascent from there. Thank you so much for tuning in with us, and we'll see you tomorrow. This guy is on our camera. He's like, we're coming home with you.
I can't believe the camera's focusing on that.
That's really cool. Oh, there we go.
I gotta get outside. 50. Dang it.
Look it up there, girl.
Okay, we're approaching 200 meters. For those of you who are still with us, do you want to see the recovery? If so, would you prefer to see the ROV view or a CCTV from the ship? Let me know. Okay, we'll show you the ROV and we'll give you a little picture-in-picture of the CCTV. So we'll give you both. There was a question before about why does it occasionally disappear. That's actually, it's getting really close to the camera. So the camera kind of has a shield to protect itself from light. And so it'll kind of get into that shield and it'll be blocked from all the ROV lights. So it'll go dark. So when you see it kind of go dark and then light and then dark and then light, that's just, it's right on the edge of the close view of the camera. And then having light shadows and stuff.
Yeah, okay, I didn't see it.
So on Falcor 2, we were recovering the ROV from the port side of the ship. On Falcor, we had a back deck A-frame deployment system, and so we would get cool shots of the props. But yeah, we were just talking about how we don't get to see the voice on the ship just because ideally we don't head in that direction with the ROV. And it's just far enough that you don't see it. But on some cameras, you can actually start seeing the ship and the gondola as we make our ascent. So if I can see that today, I'll show you that as well. Okay, as we complete our recovery, we will slowly be sliding back towards the ship. And in the picture-in-picture you see there, you can just barely see the ship. As we get closer, it will be more defined. Bonus points if you can see the gondola or the USBL pole that we use to track the beacons. So I'm going to sign off. We'll keep the stream going until we're out of the water. Thanks again for sticking with us all the way to the surface, and we'll see you tomorrow.